Hello. Hello. Check 1 2 3. Hello. Hello. వస్తుందా?
communication and embedded system. Now, without much delay, I request all the dignitaries and guests to occupy the seats on the dais. To start with, I request Dr. GAE Satish Kumar sir, Head Department of ECE, General Chair ICSVCE 2022 to come on to the dais. Now I request Dr. Sachinandan Mohanty sir, Adjunct Professor, Vardhaman College of Engineering to come on to the dais. I request our beloved principal, Dr. JVR Ravindra sir, Principal and General Chair ICSVCE 2022. We have guest Dr. Love Kumar sir from BITS Pilani, Hyderabad. I request him to come on to the dais. Finally, our chief guest for today's inaugural session, Dr. Tanupriya Chaudhary sir from UPES Uttarakhand to come on to the dais. Now, I request all the dignitaries to come forward to light the lamp. Thank you all the dignitaries. Now it's time for our prayer song. I request everybody to stand at their places, and I am requesting Srinitya from first year CSE AIML to sing the prayer song.
Ya kundendu तुषारहारधवला या शुभ्रवस्त्रान्विता या वीणा वरदण्डमण्डितकरा या श्वेत पद्मासना या ब्रह्माच्युत शंकर प्रभृतिभिः देवै सदा पूजिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा. Thank you.
Thank you, Srinitya, for the melodious song. Now, I request Dr. J.E. Satish Kumar sir to address the gathering.
Good morning. Good morning. On behalf of Department of ECE, as a General Chair of ICSVCE 2022, once again I invite all the dignitaries on the dais, our beloved Principal Dr. J.V.R. Ravindra Garu, and today's chief guest Dr. Tanupriya Chaudhary Dean R&D, Dehradun. Similarly, our Professor Sachi and Dr. Lav Kumar from BITS, Hyderabad. So, and my dear faculty of Department of ECE, head of the departments, and deans, and students. So it's a great privilege and honor for Department of ECE to organize such an international conference as the second time. So I have initiated this effort in the year 2021 during pandemic time, and it was conducted in purely in online mode. So now this year we want to go with the physical mode, and we requested the principal, and he generously approved our request 8 months back, and subsequently with his guidance and support, now the day has come. And we thank the management for providing all necessary infrastructure facilities and support to organize this event. And also the organizing committee and the core committee, which is working from past 6 to 8 months to make it into reality. And we thank Dr. Jabbar for helping us in get the approval from AIP conference proceedings. And so far we have received 1 or 2 papers from different parts of the country, and we have taken reviews from prestigious institutes, those having research experience in the tracks which you have given in the conference. And they have took their valuable time, and they have evaluated, and finally they have taken 34 papers into consideration as per the publication standards given by AIP. And then the final part comes, the organizing committee, which has done meticulously, and now the conference has come into reality. So with these introductory words, then I will ask our beloved principal and chief guest to inaugurate this conference. Thank you very much.
Good morning, everyone. So it's my privilege to introduce today's guest of honor, Dr. J.V.R. Ravindra sir. He is a professor in the Department of Electronics and Communication Engineering and heads Vardhaman College of Engineering as the principal. He holds a PhD in VLSI design from IIIT Hyderabad. He received both master's and bachelor's degree in signal processing and electronics and communication engineering from Usmania University, Hyderabad. Sir has authored more than 100 papers in reputed journals and conferences and holds 5 patents. Now I would like to invite Dr. J.V.R. Ravindra sir to address the gathering.
Good morning. Thank you, and respected dignitaries on the dais, my fellow colleagues and dear students. So I just would like to say a couple of words regarding conference. My talk is only to students, because the other faculty and the dignitaries know about what I'm going to talk about. But you must really understand the importance of the conference, symposiums, workshops in your career. If you really talk to any research scholar who is doing his PhD or MTech or MS, most of the time they treat that the journals are very, very important. Of course, most of the universities are doing some kind of the framework for the journals, but attending the conferences and symposiums and workshop will really nurture your talent. The conference is a kind of a platform where you can interact with key persons in those fields. Suppose if you are really interested in artificial intelligence or robotics or VLSI. So in the next 2 days, we have arranged those sessions where you can directly interact with them and understand what kind of research is happening in their universities or laboratories and what actually you know. So the conferences are basically to build a lot of networking and to understand the real-time knowledge. So this kind of networking will also help you in the future. Suppose if you would like to really do your MS in BITS Pilani, or where Tanupriya Chaudhary sir is working, the Dehradun. So those places you can really ask them for the next steps, right? So that's at career-wise, they are very important. And building the network, it's very important. Transforming the knowledge is important. So at least in your BTech career, attending 2 to 3 conferences are very, very important. You just have to move outside the state, even sometimes if possible. The financial support is really possible, sometimes out of the country also, to present some papers. Trust me, there are some conferences which have been conducting from last 55 years. There is one conference in VLSI which is called Design Automation Conference, and this year it is happening in US, most of the time of course in US, and that is 59th conference. And there are a couple of conferences which have been held last 60-65 years. You should understand the impact of those conferences, and some conferences are really good than the journals, right? So journals is another kind of thing where you have to send your paper and you get the reviews, and there will be no interaction with the delegates you say, or the people you say. So attending these conferences is very, very important, and you need to also attend the panels and the sessions you should attend, understand, if not 100% of course, but at least 10-15%. Sometimes, I'm sorry, sometimes at least you get a path to your research, right? So that's what we have been telling in various platforms, that research is not a big thing. Research, you have to search it again for better results. So somebody has given a result, you try to give a better result compared to that. It's not that they have given already a result, so why should I work on it? It's not that. Research is not that. So we have to always move forward to give the better results. It's not that they solved it, closed it. No. You can open a problem which was closed 10 years ago, and you can close a problem which was opened 10 years ago. Both are research. Research does not mean that you have to give always better results. I have seen some research papers where they tell you what you should not do. That is also a research. So for a particular architecture, rather than doing, they tell you don'ts. So don't do this, don't give 5 volts there, don't give this, don't give that. So therefore, that is also a kind of research. So it can be seen in various ways, right? It's not that always you have to give a better results. So attending these conferences, definitely, I'm pretty sure that they'll give you a lot of knowledge, and keep doing it. Try to understand what's happening in the sessions, and interact with them, talk to them, right? And then improve your knowledge skills. Thank you very much for your kind attention, and thank you very much for your patience. Thank you.
Thank you very much, sir, for the encouraging words. Now, it's my pleasure to introduce our guest today, Dr. Lav Kumar, sir. He is currently working as Assistant Professor in the Department of Computer Science and Information Systems, BITS Pilani, Hyderabad. He received his PhD in Computer Science and Engineering from NIT Rourkela under the supervision of Professor S.K. Rath. His current research interests are in the area of mining, software repositories, machine learning, text analysis, testing of AI systems, software analytics, and social media analytics. I request Lav Kumar sir to address everyone.
So good morning everyone. So first of all, thanks to Vardhaman Engineering College for organizing the second international conference on Advanced in Signal Processing, VLSI, Communication and Embedded Systems. Okay, so I am not in the area of electronics because I am working in the area of computer science and engineering. But sir has already mentioned about the importance of the conference. Same like in the bids also, we are always motivating the student to go for the conference, to submit the paper in the conference. So that's why in the bids also there is some courses like that. You are doing the study oriented project, design oriented project, lab oriented project, where we are also giving the credit to the student. So three credit courses like that, design oriented project. So where the student will, the whole semester the student will work on some project, and after that they will submit the paper or submit some good conference. So now in the bids, the trends is totally different. Now in the bids like that, some students are totally focused on the placement, but out of that, 20% students are also interested for the research. And if you are going to check in the bids, regularly you will find like that the BTech second year, from the second year students are also publishing the good paper in core conference, the core B, core A and core C type of conference. Regularly they are working on the research paper. So recently our 4 paper accepted in core B, and those all are from the BTech second year students. So after first year they start working on the research paper. And how we are motivating the student? Because we have given the credit. So instead of doing the registration for some other subject, why not we will do the registration for the study oriented project, design oriented project and lab oriented project. And after that, if their students are going for the MS, because in the bids the trend is little bit different. Some are going for the placement and some are going for the MS. And if the students are looking for the MS outside India, definitely they will go for some publication. Because if you have some good number of publication, definitely will get the weightage during your MS admission. So then again I am going to encourage all the BTech students who will participate in the research paper. Okay, you will also plan to submit some paper in good conferences. Good conferences means you will start from some local conferences, but finally you have to make the goal like that. You have to submit your paper in some core conference where you will get the real good feedback. So at least you will plan for the core A, core B or core C type of conference. So how you will find, there is one site called core conference ranking. So when you will type the conference, you will get the what is the rank of the conference, and where the acceptance rate is almost maximum 10 to 15%, not more than that. So where approximately 1000 papers are coming and only 120 papers got accepted. But if your paper got accepted, there definitely will get huge weightage during your career. If you are going for the, even if you are going for the company, in our college also many students are getting the job in research department. Same like that in Microsoft, initially they got as a development, but after 5 to 6 months they got job in the research department of the Microsoft, research department of the Flipkart, research department of the Amazon. Why? Because they are regularly they are doing the research. Either they are doing the formal or they are doing the informal. So this is the good way to interact with the faculty, good way to attend all the session. At least you will try to understand how the research is going on, how to find the motivation, and after that you have to either you have to select any one of the topics, because here if you are going to check approximately 40 presentations are there. So at least you have to find some motivation out of 40 publication. At least you have to select one publication, and after that you have to extend the same area. So now, so I am the same like that. If you are looking for the better career, then definitely instead of going for, means you have to go through your subject, but also you have to extend your research work. Also plan to submit some good paper in journal or conference. Okay, so thank you very much for Vardhaman Engineering College for organizing these types of event. Okay, thank you.
Thank you, sir, for your kind words, and I'm sure a few of our students will be encouraged, motivated to continue research in the core fields. Now, it's my honor to introduce our chief guest for today's session, Dr. Tanupriya Chaudhary, sir. He received his bachelor's degree in CSE from West Bengal University of Technology, Kolkata, and master's degree in CSE from Dr. MGR University, Chennai, India. He has received his PhD in the year 2016. He has 12 years of experience in teaching as well as in research. Currently, he is working as Senior Associate Professor in Cluster of Informatics in School of CS at UPES, Dehradun. Recently, he has received Global Outreach Education Award for Excellence in Best Young Researcher Award in GOECA 2018. His area of interest includes human computing, soft computing, cloud computing, data mining, etc. He has filed 25 patents till date, and he has received 16 copyrights from MHRD for his own softwares. He has been associated with many conferences in India and abroad. He has authored more than 250 research papers till date. He has been associated with many conferences throughout India as TPC member and as session chair. He is a lifetime member of IETA, member of IEEE, and member of IET United Kingdom and other renowned technical society. It's our privilege to have you over here, sir. I request Dr. Tanupriya, sir, to come and address everyone.
Thank you, ma'am, for your nice introduction. Good morning to all of you. Good morning, sir. Good morning, all of you. Respected dignitaries on the dais and off the dais. First of all, I want to thank you, Principal Sir, for contacting me and inviting me over here, and also HOD Sir, Satish Sir. And Principal Sir is definitely very keen to research, as my friend Satish Sir told me. Since 1 month we are in contact that how we can deliver or develop research ideas in Vardhaman College of Engineering by the help of this conference. Today, my goal, earlier I thought that I'll be delivering some lecture or keynote on a specified topic, which is aligned to International Conference on Advances in Signal Processing, VLSI, Communications and Embedded Systems. But in the morning, as per the discussion with my friend Sachi Sir, I thought that without taking much time, if I can discuss with you all regarding the research and how you can publish good number of papers or quality papers in quality journals, what are the basic thing before publishing a paper, and what are the ethical standards, how you are finding the ethical standard, and how to take the funding also. As because since last 2 years, many of the journals are open access. We are having some good or bad knowledge, you may say, that open access might not be good. Someone says open access is good, but it's taking so much of money and all. But being an Indian, how we can submit open access journals, how to find out the funding and all, and without funding also how we can submit, these discussions I'll do. I am basically from University of Petroleum and Energy Studies. I am having one international research lab also there. And I have discussed with our principal sir, if possible, if we can collaborate somehow, by the help of that, we will definitely collaborate by the help of the research. I just want to deliver the keynote along with my laptop. May I please? Thank you. Yeah, thank you.
Thank you, sir. We are looking forward to your keynote session. So before that, I request all the dignitaries on the dais to come forward and release the souvenir of the conference. Thank you, sir. Now, I request our chief guest, Dr. Tanupriya Chaudhary, sir, to deliver his keynote session on recent advances in human-computer interaction.
For internet, I need internet also. Internet connection.
वाईफाई कनेक्शन वो वाईफाई कनेक्शन रखो it is automatically connect.
No issue. I'll
Oh,
try.
the software
I'll
will-
connect. चलो.
The software will download. We can download that.
अरे हो जाएगा कंते पर्सन नोट थोड़ी हो जाएगा.
No, no,
It will be done.
No, not there is.
हो
For
जाएगा.
connecting this one, one software is required.
This one.
Uh,
Okay. Which one?
we will download here. How you can put yeah.
One minute. There is some issue.
Okay.
Hmm.
Shall I copy in this laptop, sir?
Yeah, I can do.
Yeah, install, sir. Yes. This is
So this AC can be.
Shall I put off, sir?
Yeah, but the temperature might be higher. Yeah.
Increase the temperature.
Yeah. Higher.
Sai. AC. Tagi. Intel Wi-Fi, okay. అది ల్యాన్లో పెట్టేసారు.
It will be connected by Wi-Fi.
Yeah, yes, sir.
Some scan number is there.
Yes, sir.
Now it's done.
Yes, sir.
And internet also.
No, internet, sir.
Yeah.
Is there a LAN? Is this LAN?
Yeah.
port is
In LAN port is not there. Yeah.
but
Wi-Fi I can do na. I can hotspot I have on. Yes, I think it's.
connect only Wi-Fi, internet, Wi-Fi, internet, or option only projector, sir.
Okay.
At a time, both we can't. Otherwise, we have to put the LAN, sir.
LAN is not there.
External cable is not there, sir.
No.
Sir, otherwise, if you give in pen drive, sir, that we will play in the desktop, sir.
But it will not work. I have to show from here.
We need to connect us, sir.
Sir, connector you might be having na with this VJ port. Yeah. And this. दीजिए, यहाँ दीजिए। ये कोई भी नहीं चलेगा सर। Don't come sir. This is charger port. This is charger port. How will come? But you can add. This will not come, sir. You are not having that. Huh? In institute you are not having. In their net is working. Okay, leave then. I am giving by pen drive. Sir, how do this come? This is new generation laptop. This will not connect, sir. Yeah. Now I think it will work. And here the connection is there. Yeah, we can start then. Thank you. Good morning to all of you. May I start or should we wait for a few minutes? Yeah. Thank you. Earlier I thought, as discussed, that we'll be delivering some keynote on human-computer interaction. Though I think you all might be knowing what you mean by human-computer interaction. Human-computer interaction means some interactions which human can be interacted by the help of some computing devices. And BCI also is a part of human-computer interaction. BCI stands for Brain-Computer Interface. In 2016, IBM was telling that BCI can be developed with the help of near about 1 crore INR. But on the day when I was working with Amit University, I thought how we can design this type of things by the help of Manesar Brain Research Institute. My friend Sachi sir is also there with me at that time when I was delivering or developing that product. But I thought that how this can be done. That means if you are thinking something that can be come directly on your system. This can't be done without the help of any great laboratories and basic amenities. But the basic amenities cost was near about 2 lakhs or 3 lakhs rupees just to develop the system. That means the architecture. Do you know anything about BCI, brain-computer interactions? Anyone? Anyone from the audience? Okay, that time I was driving by bike and I was thinking how it can be done, the design part. I was not so happy, that's why somehow I throw my helmet down, but that time the throw was so good, that's why the helmet was broken. And from the helmet, some skull came out. And I thought that we can develop few of the points or few of the scissors over there or the points in that helmet skull. Then within 1 and 1.5 years, we have developed such kind of systems. By the help of that, you can understand, or you can, if you are thinking that the letter A will come on the system, letter A will come. If you are thinking that the system will be shut down, system will be shut down. If you are thinking an apple can come in the system and apple can come. This is like a design. That's why I'm telling it to you.
if you are doing some design, the design must be some interactive one, otherwise low cost. Earlier we were having these type of watches, but maximum number of times students are having right now smart watches. And if the smartwatch design is so reliable and the students can buy it, then definitely the cost also needs to be efficient. That means design efficient, reliable, and also the thing needs to be taken care by students or old age like peoples or middle age like peoples or like that. That was the thinking that behind the design of the HCI, means human computer interaction. But today when in the morning I were discussing with my friend, I thought that rather than giving a lecture on a specified topic, why not we give the lecture that how the research can be done. As because the research can be done, I know, since 2015 to 19. It will take near about 4 years to understand what actually the research is, basically. So first of all, though the lecture will take near about 2 hours, and also I have prepared for 8 hours also. I have been given these type of lectures so many institutions throughout India and abroad. But I have cut somehow so that the basic points and the basic amenities you may understand and you may apply on your own research, or some ethics which you may apply on the research. We know that publishing paper is very good. We know that targeting journals is very good. We know that we might be having the Turnitin. Turnitin means a software. By the help of that you can check the similarity index of your paper. These points I'll be discussing today. First of all, I'll be coming directly to the research network. First of all, research network, what does it mean? We are at Vardhaman College of Engineering. If we can collaborate somehow the research with the other institutions as well by the help of Google Scholar or something else, you can do like this. I am just telling it to you how officially you may do that. You directly search for Google Scholar. That means any Google Scholar you can search. You can see here brain computing. I am just clicking. When I'll be clicking, in the brain computing, so many other faculties are also there from India as well as abroad. If we can connect with them, that means Claude Frassen or Mohammad Khaza Mainuddin, Hamdi Ben, Irfan Mustafa, then definitely your research network will be higher than ever. This is the way how I can move on, though this was not told by any book or anywhere else. You can do by your own research. Then you can add this person in your own group and you can ask them for collaboration or research feedback, or if you can write one paper or some project in Vardhaman College of Engineering or any other place where your friends are there, then you can ask these persons and how the project can be developed and how the project can be integrated more and more. Not only in the field of only brain computing, other fields are also there. You may find also what are the other researchers in your institutions who else are working with you. As because in my institutions near about 700 faculties are there. It's not possible for me to go there for every person and every student one by one or 1:1. If I can mail them directly from here, it will take only 1 minute. Otherwise, you can mail them by BCC. Then definitely if you can send an email up to 100 times, then definitely 10% of the person will respond to you. Response is like that. Then I am just again coming to that points which actually I have been written over here. These points are same: preferred school status for research projects, accreditation for research undertaken in the school, implementing research and inquiry in school, dissemination and publications to act the communicator and disseminator of the current research evidence, digest and signposting, building research capacity in school, access to online action research program and tutor support. And for the other faculties as well, that it's not possible to determine elsewhere or Springer that Mr. ABC is working in this college. You have to be volunteer enough. That means in everywhere there is a form, in elsewhere, in Springer, in Wiley, in Trailer Francis, these all are the publisher's name. If you can just go over there in that link and fill that forms, definitely within 1 week or 1 month, you will be notified for a reviewing. What is the basic act of the reviewing? If you are reviewing a paper for a journal 2 years, 3 years, then definitely if you can submit a paper on that journal as a author, then the additional reviewers or the editor-in-chief or the associate editors will understand, okay, ABC is no to me, somehow I will not directly reject it. Maximum time, actually today, in today's world, maximum journals are rejecting the paper by saying that the paper is not up to the mark, or the paper is not aligning with the thought which actually we are publishing, or like that. That's why, first of all, try to establish your research network, then try to go it for that. And before that, you can submit your research paper in conferences, in ABDC conferences, or sir has also told about the other conferences as well, ranked conferences, so that you can meet the other persons or other faculties over there. And somehow, by the help of that faculties and colleagues, you may get a good research network. These are the process of professional learning. By the help of that, that means when research is seen as a body of knowledge and teachers may or may not choose to make use of it in their practice, when research becomes a professional learning process, it can have a deep influence on how they understand research and may lead them directly towards more active engagement in undertaking inquiry themselves. You won't believe, by the help of that, I am having near about 16 students in my BTech 4th year. As because we are having near about 500 students in AIML, but as 8 same students are doing their own job, that's why we are giving them online support. But the 16 students are coming to our lab and doing the research. 50% of the students right now in today's date in IISc Bangalore, they are doing their direct PhD after BTech. But how? They have done within this 6 months published the papers. How? I'll tell you how to publish your good papers in less time. That means I'm not telling you you have to go like a rocket plane, but some ethical standards have to be followed, some other points have to be followed which are basics in the design or the research. Now you can see directly I will be coming to sorry, this integrity part, means research integrity or academic integrity, what is plagiarism, types of the plagiarism, how you can prevent it, how to detect it, and the plan for your academic awareness drive. This is for actually for the faculties, and students may listen please. Plagiarism is something that when you will be submitting a research work, the research work might be similar to other published work also, as because you will be taken your research from the published papers only. But how to take care of that? These are the points. And plagiarism, there are some softwares by the help of that you can directly check the plagiarism ratio. Turnitin Authenticate is the best one. Don't go for any online tool which is available on Google, as because if you will be submitting there, your paper will be saved on that repository, and someone from the other institutes, means outside of India, if from China or Japan, someone is checking your paper from that Google position, they can publish it immediately, and or after changing the same. That's why rather than going by Google, you can go for Turnitin or Authenticate. Now you can see what do you mean by the originality. I have been taken, it is necessary one should always stick to their own originality and creativity for differentiation. Without copying only, we are able to be here as we are now in terms of development. One way to protect the originality is by the copyright, IPR and publication. I think you all might be knowing by IPR. IPR is something that means intellectual property rights. In these days, we are publishing number of patents as because government of India is encouraging patents. But the patent is costing near about 9,000 if we are filing by our own, and by institution if we are filing it is 33,000. But the meaning of submitting a patent and submitting of copyright is somehow same. How it is same? Copyright is also intellectual property rights. That means if you are developing a software or if you are developing an application, definitely if you can file the copyright, then it is also similar to patent and costing also near about only 500 INR, only 500 INR, and your patent will come near about 5 years it will take to grant if it is aligned, sometimes 3 years, and within 1 month your patent can be published. Published does not mean the patent or the design is very fine. You have to take care of that. Anything can be filed. If you can file anything ABC, that can be filed and that money can be taken from your side. But if you can file a copyright, if that be cancelled also, it will take 500 rupees. But you can understand how to file a copyright. Just you have to go copyright.nic.in. You have to create, I am showing it to you. This is not written anywhere in the websites. You just go over there, create your IDs, then you can understand what, then you can file that. I'm just showing it to you, how you can check. I don't know, the internet is taking some time, but if you can submit there, yes, you can check, submitted and registered will come over there. And if you can copy this one, that means this one, and directly paste to Google and asking copyright status, by entering the diary number, the copyright status will come up. But how it is helpful for your own institution? It is helpful in NBA accreditation, NAC accreditation, IET accreditation, ABET accreditation, and NIRF ranking also. And what do you mean by this ranking? If the ranking is good enough, then definitely you will be listed in good engineering colleges. More number of good companies will come over here. Only the faculties can't support you without the help of the students, as because there might be 50 faculties, but the students are near about 1,000. If the 1,000 students are coming forward and 20% of the students are filing the copyright, then definitely the IPR will go up. That is a process behind the same. But before submitting an IPR, please ask your faculty how to proceed it for general queries and all. Then you can see the society earlier doesn't know the plagiarism, but you can see that many good number of pupils are under plagiarism. That is why please make sure your paper is not be having much similarity index than the other. That paper cutting I have taken directly from the news channels and all for your institutions to deliver the lecture. You can see the plagiarism in the educated community. Earlier also in 2016, this is not known to me in a very good way. But that time university is providing that software and all, then we understood that okay, this is the meaning of the plagiarism and all. That's why I'm just providing you the knowledge and the information about plagiarism. Then you can see these paper cuttings also. I can't tell you, but you can see it. And you can see also the student communities also. And haunting for life means if you are under plagiarism, you must not be set for an academic job, or you can say in company also. Now the academic integrity, you can see this is for the institutions. Academic integrity shall mean the intellectual honesty in proposing or performing and reporting any activity which leads to the creation of the intellectual property. That means how it can be done, creating and expressing his own areas of his work or like that, acknowledging the sources of information, that means the references. Whatsoever references you are using, that must be given as a reference. Now the thing is that I am giving you a short story of fraud. In UK, there are some institutions, you are submitting a paper, this is for faculty. You are submitting a paper and when you will be checking the same, that after publication, the plagiarism is near about 15%, but from the same source, it is coming near about 10%. Then from UK, one person will call you, and also the person will connect the other person from where the plagiarism is having. And they are telling you have to pay such amount of rupees to him or to her, and 50% will be taken by them. That means this is an online fraud. And to prevent the fraud, when you will be submitting a paper, please make sure in your plagiarism report, it is possible that some reference, it might be not enter in that paper or somewhere else. That means in that paper, some 20 references we have given, but some references we have not checked, that's why we have not given. This is truly possible, no issues in that. That is why by the help of that plagiarism report, when we can check that, okay, from this paper also some similarity index is coming, that's why immediately please put that paper in the reference list and cite that paper in the proper way, so that the plagiarism will not come after the publication. That means today I'll publish the paper in this conference, and that paper is not possible that within tomorrow the paper will be published. The paper will be published after 3 months or 4 months. In between these 3 months or 4 months, same type of ideas, somehow 3 to 4% of your ideas may be submitted by the other researchers as well without copying your work. It might be possible that what I am thinking, the same is thinking by Sachi sir. It might be possible. He can submit the paper without having my interest. Don't know that it might be my interest or it might not be my interest. It can come. That's why please make sure when you'll be submitting, the plagiarism ratio must be less than 10% or below 10%. Already I have told you about what you mean by plagiarism. Now you can see the plagiarism types. Second source, that means inaccurate citations, invalid source, misleading citations, duplicacy, self-plagiarism. Self-plagiarism means, if you can see, I'll be telling you how self-plagiarism will come. In Google Scholar, self-citation cannot be detected. But in Scopus, self-citations can be detected. There are some softwares, by the help of that, they can detect the same. Now you can see, paraphrasing is also coming under plagiarism. Rather than paraphrasing it, you can rewrite the sentence by your own, otherwise you can provide some of the tabular informations as well. Some other points like unethical collaboration, verbatim plagiarism, complete plagiarism. This is intellectual theft or stealing. These 10 points are very, very important while you'll be doing in the research, as per the ethical research community. Please make sure these points need to be seriously taken care of. Now you can see this is meant by invalid resource or misleading citations. That means the citation has not been given. This is self-plagiarism. Please don't use your own research work in PhD also. Try to rewrite it by the help of some table or some figuric response. That means I have published some paper on my PhD on soft computing. Now, if I want to publish same type of thing, how can I publish it? You may use some software by creating some of the figures, or you may use some tabular informations in it. Figures means you can use some VOSViewer softwares. By the help of that VOSViewer softwares, different types of figures and different types of references can be added in a single page. Near about 160 or 200 papers also can become in a single page. The paraphrasing, about the paraphrasing and all I have told you already. This is repetitive research. This is replication, author submission violation. This is Vardhaman plagiarism, Control-C, Control-V. This is also an intellectual theft. Complete plagiarism you all might be knowing. Resubmitting the same paper on another conference is not been taken care of. Now how you can prevent it? This is the basic thing. The best approach, of course, is to prevent plagiarism for occurring in the first place. Here are some suggestions from my side. Give students a clear and explicit definition of plagiarism at the beginning of the semester, preferably on the syllabus. Make a clear distinction between the acceptable collaboration, plagiarism, preferably on the syllabus, because these distinction can vary from discipline to discipline or from department to department. Students can become confused unless the distinction is spelled out explicitly for each class. What actually we have done for the same in our institute. Not for the plagiarism, to encourage the students. There is 3 credit or 2 credit in the laboratories. We have been given throughout 4 years. If the students are interested, they can take a course named ISR, means Intellectual Study Research. And by the help of 6 semester of a faculty or 2 faculty, they have to publish one research paper in a journal or a conference that must be indexed in Scopus. Later I will come for the students what actually Scopus is. In this way, other universities or other engineering colleges also already VIT is going like that, MIT is going like that, and also SARS Institute is going like that. You can also go for that also. Now, some creating assignments that encourage or the originality and discourage the plagiarisms. We can create the assignments. We can take a software like Blackboard. By the help of that Blackboard, if you can submit your own assignment, the assignment is plagiarized or not, it will come down directly. Create writing assignment that have several parts like a proposal, annotated bibliography. That point I have told right now only by the help of VOSViewer software how bibliography can be taken care of. Then request photocopies of all sources and have students email you a copy of their essays. What actually in IEEE, a few year before, one of my friends mistakenly submitted one paper by a student. It can be done for the other institutions as well. Like some of my students are submitting my paper without having any knowledge of mine, because they are doing the research under my guidance. But the paper is coming plagiarism after publishing in the IEEE. The IEEE will blacklist that person immediately. Then that is the actual problem. That's why before submitting a paper from the students, please make sure you are having in email or you are having in photocopies also the same thing. Please make sure. How to detect the plagiarism in our university? We have done like this, like AIDP, that means Academic Integrity Disciplinary Panel. In the school, AIIP, Academic Integrity Investigation Panel. And the department Academic Integrity Panel. That means from here, my paper will go to here, then here. Then definitely when someone is submitting a paper, they will making the plagiarism less or similarity must be in less. That means less than 10%. The warning signs and all I have been already told it to you earlier. Unusual phrasings, noticeable unevenness of style, concepts. That means if I have written like this, few of the papers, concepts that in between no space is there, in many cases, that is also coming under plagiarism in the journal, if you can find out later. Some detection tools already Turnitin and Authenticate I have told you. These are the drives we are following in our institutes. Preparations in R&D, initial training at the schools. Then we are training the trainers approach. That means we are having near about 150 in CS department. We are training them how to detect this plagiarism, or there is a, if you are using Turnitin also, you can check what is the basic issue if you are not having a proper knowledge of Turnitin. This is the Turnitin background. If you are logging over there, and if I am submitting a paper like this, you can see whenever I'll be submitting, the plagiarism must be less than 10. If in the edit assignment settings, this settings is no repository, then your paper will be directly saved to the repository of Turnitin. Please make sure the faculty members also, when you will be checking through plagiarism net tools, these points need to be fully taken care of. Otherwise, your paper will be saved in Turnitin repository and it will take near about 6 to 7 months to delete the same. Though I am telling you how to delete it within 24 hours. If you are belong to the same institute from Vardhaman College of Engineering, and if Vardhaman College of Engineering have the same rights of using Turnitin, then immediately from the library you just email to USA person. USA is the main office of Turnitin, and giving your class ID, then immediately within 24 hours the paper will be deleted. Otherwise the paper will not be deleted. Please make sure of that. Now you can see directly I'll be coming for that research activity. Already Principal Sir has told just 30 minutes before that how to write and what not to write. This keyword he has taken. You can see by the help of this, I'll be giving these links to Principal Sir so that, or the HOD Sir, so that they can share. These type of things you can check before submitting a paper in basic journals. That means how to write and how not to write a scientific review articles. And you can see the review articles is not too old. The review articles has been published in 2020. The section snippets have been given. You can download the section snippets also if your university or college have the subscription. Otherwise, you may use SCI Hub. But recently, SCI Hub is switched off for Indian network. You may go for VPN, virtual private network. It will take 340 rupees. Then you can access this SCI Hub for Switzerland or for Portugal or for any other European countries. Then immediately your paper will be downloaded for that particular time. You can use for one day, whatsoever the downloading options you want to do. That is why these positions and options are already given. That means how to write, the responsibilities of the authorship, the science of writing the review article, figures and tables and references, how to give. One important point, when in the morning I was discussing with Sachi sir, that a paper to publish and a paper to format will take minimum 5 days. Or some research scholars are telling it to me, okay, it will take near about 6 days. May I know from your side that how many time it will take to format a paper? Anyone please, as because if the lecture is not interesting or exchanging the ideas, there is no mean of that. I came directly from Dehradun, from Himalayan region to Hyderabad. That's why your interaction is also important. That's why I'm asking, if you want to submit a paper in a journal or a conference, and if the format is somehow different, how many days generally it will take? Yes, ma'am? For research scholar, it has to be taken 5 minutes or 1 minute. There is a software named typeset.io. Typeset.io. You may check that software link. The price is 5 years. For 5 years, you may use for only 1,000 rupees. You may make a group and 10 to 20 pupils, and you may use that software. I'm just showing it to you. The softwares, how the software is. As because when and Sachi sir is doing the research, Sachi sir is telling, okay, this paper is not suitable for this Willy journal. We have to submit in Springer journal. Immediately I have to submit. I am telling Sachi sir, how can I submit? Then Sachi sir is telling, okay, go for that link. Then definitely it will be done. You can see Massachusetts, Stanford, Oxford, Cambridge, Harvard, everyone is doing. Then why not we? It will take only 1 minute to format any journal, any conference, any paper. Please go forward. These are the basic tools. Before going to research, you need to understand what are the basic tools and how these tools need to be collaborated. Now, the other points which was given here, that means you can see that figures. Drawing the figures, definitely you can see these. This is a simply one example of draw.io. This is free of cost. If you can take this figure, then definitely your figure needs to be unique one. And directly copying and pasting a figure from any other source again will come under plagiarism. That's why try to do by your own. It's I have checked in my own journal also. I am having 3 to 4 journals in Springer that authors are submitting the papers just directly taking the picture from the Google or from the paper and giving the reference. This is not the right way. If the reference is mine, I can claim the money and I can retract the paper. Since in the COVID time, the retractions is going higher than higher. Retraction means if we are not following the proper strategy or the ethical research or somehow plagiarism or somehow like false collaboration, then definitely the journal EIC means editor-in-chief, have to retract your submission. And this is a very bad act of the authors. Then that is why please make sure you are not doing that. I understand that you definitely will not do that, but this information need to be shared. You can check these links also. The links I'll be providing it to you, that the abstract, how to write, the avoiding pitfalls, the example from the experience, how you have to be give, creativity and the benefit, and definitely the acknowledgement. If it's possible that in that paper, fourth author, fifth author, not possible from your side, they have not given some points from your side or from their side, you may add in the acknowledgement side also, for acknowledging him. Now you can see this one, groundbreaking research from 7,000 plus publishers, and these all are already available online. You may check online, but the thing is that if our university or the institution is not having that collaboration with that institutes or that company or that publishing house, then this will not open in my system. But how to take care of this? If you can send the EIC or the associate editor your CV and you want to become a volunteer of that journal, then definitely within 5 months you can be a reviewer in Elsewhere or Springer or any other good publishers as well. What is the basic benefit of it? Elsewhere will provide you 6 months Scopus enlightenment. That means you can have the 6 months Scopus ID and Scopus checking from your own link or own mail ID. Then definitely you can check the other Scopus papers as well. Now Scopus, what do you mean by Scopus? For India, Scopus needs to be done, that means for NBA again, for the all rankings as well. Why I am showing it to you? This is the Scopus one for the citations and all Scopus, SCIs, SCI, other SCIE, ESCI, everything is there. Now I'm just showing it to you that how the groundbreaking research is doing. You can see groundbreaking research from 7,000 publishers are directly covering one umbrella, which is Scopus. That means if it is Elsewhere, definitely it will come, as because it's a Elsewhere sister concern, as well as Springer, Trailer and Francis, Wheelie, Snevenger, then all the other publishers who are under Scopus, it will automatically come. You can see that how empower the cross-disciplinary research. Why I am telling it to you, cross-disciplinary? I am sitting for some time, as because I am having some back pain. Cross-disciplinary means in 2020, 21, in COVID days, there are many journals coming outside. There is a flood of computer science special issue. But if someone is not having a good collaboration or good thinking or making a paper somehow little bit different, how you can go it for that? In my lab, I thought, okay, why don't we go for some food technology? Or why don't we go for some vegetables? Or why don't we can make our own data set? Then we can go for a collaboration with Jadavpur University, Kolkata, and we have made near about 30 data sets. Generally, you are uploading your data sets where? May I know? In which place? GitHub. Rather than GitHub, any other place? Kaggle. Yes. Any other place, please? But when you will be submitting or repository of Kaggle or GitHub, when someone will be citing your link, your name will not be there. But if you can use RoboFlow, your name will be there. And if your name will be there, then definitely the paper also which you have written by the help of that data set, that will also come up. Then only the paper will be cited. And your paper, if citation will be increasing proper way, in ethical way, then definitely your institution will be also going higher. It is not possible in one day. It will take near about 5 years to establish these networks and to make an outcome from these networks as well. That's why try to make your own network in some different cross directions, like food. If I am telling my story, you can add your own story also. I am showing it to you by the help of Google Scholar so that you can understand. You can see this is one paper right now came in SCIE. Allergen 30, detecting food items with possible allergens using deep learning based computer vision. Yes, we are having some ethical collaboration with other peoples also, but the faculties and the students, by the help of that, Mayank is a student who is right now doing his PhD from IISc Bangalore, which I was telling before some time. Same for Nikunj Bansal. They are also, the Nikunj and me are also having one paper in Nature. Publishing a paper in Nature is so toughest. In our region, only 5 to 6 papers are under Nature. The student who is Nikunj Bansal, by the help of only one publication, his candidature has been selected in Amazon, and he is right now doing research in Amazon as well as pursuing his PhD in IISc Bangalore. You can imagine, from IISc Bangalore, Saturday, Sunday he is doing, and from Amazon he is doing from online. And he is still taking near about 3 to 4 lakh rupees per month. And Amazon is supporting him. That means paper publishing is not a very big task. If you can give some time, and if you can associate with some of the faculties are here, Satish sir is there, Pramod sir is there, Sachi sir is there. If you can collaborate with them, definitely your paper will come up. And if the paper will come up, then the funding will come up. Now I am coming to the direct to funding. In recent days, MDPI, Hendavi is taking near about $2,000. But how to cross these funding from Indian background? There is a way, if we can add somehow from less income country like Ethiopia, Bangladesh, then the paper can come up. But again, there the author list maybe go higher. But why they are coming? As because we are not having the money. This is general. By publishing a paper, and if we are giving near about 2 lakh rupees, it's definitely a huge one for an Indian. That is why, if you can, before writing the paper, if you can target the journal, and you can tell that, okay, I am having one paper, I am thinking to write a paper in the journal, and I am not having any specified source of income, and I am not having any internal or external funding from my university as well, and also from my collaborators as well. And the letter need to be forwarded to the EIC, as well as if you are submitting the paper in Springer also. That means if your paper has the capability to publish online without having any money and in open access, and if the publisher wants and that publisher accepts your proposal that, okay, this paper is having good number of quality, then definitely the paper will come in open access. I am again showing it to you. This paper is not open access. I have not requested them for open access. But I have requested this paper for open access. These all persons are from my university. And you can see here the paper is open access. For my university to publish a paper in Springer and paying near about 2,50,000 INR is not good for me also, and is not good for university also. You can see here all the persons are from my institute. That's why before submitting a paper, please contact first of all to your guide. Then guide will channelize one letter if the paper having sound, and before sending to EIC, please do peer review throughout the Central Government Engineering College or Tier 1 Engineering College that the paper is having good impact. Then only after the impact and all, if you can submit, then this is the channel. If the paper is having good quality, then it will be done in open access. And definitely someone is telling, and I also have the same paraphrasing that open access is not good and something like that, and some universities also not accepting open access papers. But Springer, from Springer, Anindada is there. He is a senior editor. He is very close to us. He told that open access is nothing. Open access means if you are submitting or publishing a paper, and somehow for the other countries, if they are doing some research like Ethiopia, Bangladesh, Nepal, Bhutan, they want to see your paper. How they will see that? They are not having so much of money. That is why they are introduced open access. Yes, institute can collaborate with them. Manipal University has, from India only, has collaborated with Springer. If from Manipal University, 4 authors are there, all from Manipal, and publishing a paper in Springer, the paper will, if it will be accepted, then the paper will be going to open access. Likewise, Germany government also have directly tied up with Springer. Switzerland government also has directly tied up with Springer. This is come under CSR, corporate social responsibility. The social responsibility means if you are writing a paper, your research will come out in other countries as well, and anyone can see. And the basic advantage is that if anyone can download your paper, then only your paper will be getting more citation. That is why MDPI and Hindawi and other open access journals are getting more citations than the other journals which is having more quality than that. Why I am telling for the more quality? More quality in respect with the standards. Though I am not telling that MDPI and Hindawi is not having low quality. MDPI and Hindawi is having very good quality also. But in respect to the other journals, if you can do like this, then definitely somehow some linkages can be there. Now you can see how to find a good journal in respect of the subject area. Anyone can help me over here? How you are submitting a paper? How you are submitting? Time? Yes, sir. 15 minutes? Yeah, thank you. How you are submitting a paper? In subject area, if I am searching geo, you can see Earth and planetary sciences. If I am applying, 2,402 results are coming. Those every journals are indexed by Scopus. This journal is having more site score. Directly go, if you are the first time author, you may go from 1 to 50, near about number 30 page. And check what are the journals, and if the journal is aligned to your research, try to go it for that. Make a query, yes, sir. Yes, Scopus login. No, that is why they have to take help from the faculty as well. And if the faculty is not having the means login and ID, they have to request the other journals in elsewhere for giving them the review access. And then only the ID and the password will be taken care of. That's the point. Now the thing is that if you can search these journals, then definitely some special issues, some journal must be aligned to your research, and you can find it out. Then as the time is very less, I'm just telling you some other points as well. You may check directly in Facebook. There are some groups available in Scopus and elsewhere. You please go there and like that page. Then definitely all the messages will come in your Facebook. Definitely if you can tag in LinkedIn also, and other sources as well. Now the thing is that how to increase citations, and these 3 points need to be discussed for a researcher. And what is SSRN and elsewhere, and preprint, why it is necessary. If we are publishing a paper and we are submitting in a preprint, preprint means before publishing publishing any journal or publishing your paper in a journal, we are submitting a paper in preprint. Preprint is free of cost. Research Square, EasyChair are giving preprint accesses. And preprint is means CC 4.0, direct access and open access. Someone, if you are not interested to submit a paper in journal, or you can say that if you are not having good time for the reviews as well, you can submit in the preprint. Some good reviews you may have. Then the journals who are accepting preprints, you may request them, this is my paper. If it is good, or if the readers are like this paper, I may submit by through proper channel. In Springer and elsewhere there is a provision, preprints can be accepted. And not only the preprints in the acceptation mode, but also the preprints can be means likewise peoples from the whole world will be joining together with you, if that is interesting. Now the thing is that, though the time is less, how to increase your citations of your submissions. You can check, or you can have your own ID in Web of Science, Scopus, Orchid, Researcher ID. You can submit your paper in the research gate after publishing your own paper. Then Publons is definitely there. If you are reviewing any paper, your credentials will be given in the Publon. And also in academia.edu, if you are submitting or uploading a paper, the paper will be free of cost, anyone can see that. Then only immediately your paper will be directly coming to any one place without downloading or for paying any money for that. You can share your papers by the help of Twitter, Facebook. You can have what actually we have done few months before. We have made our own computer science YouTube group. And in YouTube group, we are submitting video papers. You might not be listening about video and audio papers. In coming days, these video and audio papers will be booming in the industry. As because plagiarism, there is an issue. Video paper means 10 minutes video presentation and video submissions to be there, and few journals are still accepting these video papers right now. And the video papers will be given some weightages also, and it will take very less time to publish the same. It will be given the DOI number also. DOI number means a unique number. After publication, any publishing house will be providing it to you. Already a few points I have been told to you that, but it's not possible to complete all the things. But these points you may understand that just one more point, like from where you will be seeing the call for papers. If we are searching by Springer Journal Suggester or Wiley Journal Suggester, that means if the keywords of your paper is matching, then the journal will suggest you few journals. That means the link is also, I am here right now. If anyone interested, I am just showing it to you. This is the journal suggester link. If you can submit your manuscript title, manuscript text, and the area, it will come up. Now the thing is that how to know that how many journals are there in my list? You can check by this. The 2796 call for papers right now is going on in Science Direct or elsewhere. From here you can check it out which journal or which SI is important for your paper. Then you can submit along with that. Throughout the world there are many number of call for papers which we don't know. Only we know in our circles only we are having some SI submit here. Then it might be accepted, might not be accepted depending on the reviewers or the associate editor and the editor-in-chief comments. But you can go like that. Then without having any source of your own resource, you can publish your papers directly outside. And the impact will be also very good. Now the last point, there is a boom in last few years in the book. But if the book is not indexed by Scopus, how to do it? How to deal with that? This is for the faculties. First of all, in our book, if we are submitting in a pre-Scopus indexed book series, it's fine. Otherwise, if in our submissions, if we are having near about 20 chapters, and out of these 20 chapters, there must be 16 chapters outside from India, then definitely, and the plagiarism index need to be less than 10%, and all the books and all the chapters are aligned with the series. Then definitely these books will be indexed by Scopus. We are having some books which the publisher already told us that these books will not be indexed by Scopus. Then we have done by these type of channels, and right now the books are under Scopus. You can see it's not possible for you without having proper ethical collaboration to publish good number of papers, which is definitely useful for your institutions and useful for your collaborators as well. You can see I have published till date 278 Scopus indexed paper, which is under indexed in Scopus. Then you can also publish it. Right now I am 35 years of age. You can also publish it like that by the help of some collaboration, by the help of some ethical research as well. Now as the time is not right now we are not having so much of time. That's why we have to close here. We can, these references I am having used in my presentation. And these are the works which is going now in my laboratory, like future genetic engineering fields, neuroscience, robots with AI, improving physical methods, which I have already told you regarding BCI. Then improving the generalization, and in already I told you like audio video manuscripts, improving the knowledge of how they interpret waves. You can contact me in the mail ID and the number. Otherwise, you may contact through Satish sir or Pramod sir or Sachi sir. And if you can come in our university, we can have some like introduction to AI, Python, all the things like ML, data mining things, deep learning, cognitive, neural networks, applications of ML in industries, and pattern and anomaly detection. These are few of the books which we have published and definitely under the Scopus also right now. You can see Sachi sir is also there along with me. Few of the journals right now, few journals I have been given. If you want, you may publish if your paper is aligned to that. Now, also that these books are under EAI. The EAI conference will be coming in December. I request all of you to please submit few EAI, few of your research papers in the EAI. Try to connect with some researchers throughout the world and then submit, so that the geographic capability can be taken care of, as because EAI of Springer wants the paper from the outside, not only from the Indian background. And these are the points. If you want, you may contact. Thank you. Sorry, all points I have been discussed. If we can have some more time, we can discuss these in a more detail. Thank you. Any questions, please? Otherwise, questions ki bina kaise hoga? How, without questions, that means you have not understood these points. If you are having any questions, you may ask. Otherwise, you may talk to your faculty members, as because without proper and good publications, you will not be judged enough. As because after third year, your campusing will be there. Just 1 minute, ma'am. Your campusing will be there, and at campus, if any company will come, and if they can check, okay, this student have published 3 to 4 good number of papers, then for my software specification also I can take in my team or in my research team. In TCS also R&D is there. In Microsoft also R&D is there. Everywhere R&D is there. In R&D generally they are publishing white papers. White paper means which is directly coming in their repository. You can contact with them, you can channelize the white papers in your research work. And definitely, then only your paper will be cited enough. And that person, if they will come in your college for a collaboration or for a campus drive, then definitely it will be a very good point. And they will take it as a student also over there. And one more point, if you are having good number of papers, you will be selecting in other institutions with proper scholarship in MS. MS also you will be given more scholarships. Thank you. All the best.
Thank you very much, sir, for such an enlightening talk, where we as a faculty along with students have learnt how to increase our research areas and how to increase our citations and all. Thank you very much, sir. So now I request Dr. G.I. Satish Kumar, sir, Mechanical HOD Srinivas Rao, sir, and Dean R&D JKC, sir, to felicitate our chief guest, Dr. Tanupriya Chaudhary, sir. Thank you very much, sir. Now it's time for our next plenary talk of the conference. I request Jayalakshmi Madam, Assistant Professor from Department of ECE, to introduce our speaker.
It gives me an immense pleasure to invite today's guest, Dr. Abhinav Kumar sir. Dr. Abhinav Kumar sir, he is an associate professor in the Department of Electrical Engineering at IIT Hyderabad. He done his postdoctoral research in wireless communication from University of Waterloo, Canada, and PhD from IIT Delhi. He received dual degree with BTech in Electrical and MTech in Information and Communication Technology from IIT Delhi. He is a IEEE senior member, and his research areas interest includes wireless communications and networking, green cellular networks, user network selection, device-to-device communications, and radio resource management in heterogeneous wireless access networks. Now I would like to invite Dr. Abhinav Kumar sir to give you a plenary talk on visible light-based communication for beyond 5G networks.
I hope I'm audible at the back. Okay, thank you. Can you please project the slides? Sure. Sure. First of all, thank you for inviting me for this particular talk, and thank you for the kind introduction. I'll try to keep it brief. I think we have 1 hour. 1 hour? Okay, I'll keep it brief for 1 hour. I will not go into details of my own introduction. I think that has already been done. I'll be talking about developing visible light-based communications for beyond 5G systems. At any point, if you have a doubt, please feel free to stop and ask, or you can also ask at the end. Either works for me, no problem. Coming to the motivation, how many of you have been reading news for past 2 days? Good. How much has Reliance paid for 5G spectrum? How many thousand crores? 80,000 crores. 80,000 crores is the amount Reliance has paid, or at least has committed so far for 5G spectrum. That's a huge amount, right? 80,000 crores. So it's a big amount. Now, please note, why is Reliance paying so much money? This is happening because the spectrum is finite. When it comes to cellular networks, especially for up to 5G, the spectrum we are looking at is sub 6 gigahertz and also millimeter wave spectrum, but predominantly sub 6 gigahertz is what everybody is after. Why? Because the propagation characteristic is better. You must have read that, as frequency increases, propagation characteristic drops. Like, channel becomes worse and worse. And that's the reason why in millimeter wave we are talking about small cells, but we are not talking about macro cells. So when you have seen these big towers, cellular towers close to your colleges, they are all macro base stations. And those macro base stations operate on sub 6 gigahertz of spectrum. For the matter, Reliance has been eyeing the 700 megahertz spectrum because of the propagation characteristic. The signal propagates farther. Your phone will receive more number of those dots in terms of the channel quality, right? Now, the catch is because it's a finite amount of spectrum, and it is not that the spectrum is only available for civilian use cases. Please note, we are using it in civilian cases, but the first right of spectrum is actually with the defense. So in any country, typically, if there is a good amount of spectrum available, a chunk of it goes for defense purpose because the army needs it, or the navy needs it, or the air force needs it. And then the remaining thing they give to civilians for civilian purposes, right? And that's why anytime you need a spectrum, they first go and check with the defense. Can we use it? Are you using it in any of your equipment or not, right? And below 6 gigahertz, majority of the spectrum is already occupied, right? So and we can't generate new spectrum. If there is a resource, if you're already using most of it, that is it. We can reallocate it, but we can't generate anything below 6 gigahertz.
So that's one of the motivations why people have started looking at visible light based communications. Because visible light, as the name indicates, operates in terahertz, right? And that spectrum is free. For that matter, if you have to deploy these LED lights, I don't need a license. But if you want to deploy a transmitter and receiver below 6 gigahertz on licensed spectrum, you first have to get the license. You have to first pay the money. Only then you can operate a transmitter and receiver on licensed spectrum. Unlike that, in visible light case, it's free. Anybody can deploy a light, anybody can deploy a photodetector to detect presence or absence of light, or for the matter, any modulation technique on top. So as you know, already people must have motivated as part of this conference, the demand for data is increasing. How many of you have used GPRS? I'm not asking the front two rows. They belong to my age group. So most of the questions will be for the age group, third row and beyond. Has anybody here used a Nokia phone? Nokia, which one? With GPRS service? WAP, anybody knows what is a WAP? So good old days, 10 years ago or 12 years ago, when mobile telephony was recently introduced in India or more commonly adopted in India, we were using 2G. 2G didn't have data. There's no data service in 2G, only SMS or phone. You can make a call or you can send a SMS. And then in 2.5G, they introduced GPRS, where you can send few bytes and you can receive few bytes. And everybody was so happy. I was so happy. I am one of the old users, right? So we were very happy. Now we can send data on the mobile phone. And now we have evolved from 2.5G to 3G to now 4G and headed towards 5G, where we are already looking at megabits per second. For that matter, in beyond 5G networks, we are talking about gigabits per second, right? Now, it is not that the technology is evolving faster than the demand. There is always more demand. Technology is only catching up. Even now, for example, all of you mostly would be using 4G phones. With 4G phones, there is always this need at some point, if it could have been faster, I could have played a HD video, I could have played a better game, these kind of so the demand is always ahead of supply. That's how the business works. If the demand is more, supply is less, you generate money out of it. So there is a huge demand for data. The RF spectrum, as I already illustrated, is very limited. So one way to bypass this problem is to use the visible light spectrum, which is from 430 to 770 terahertz. To give you a perspective, in 4G, when you are communicating with the base station from your phone, you hardly need 20 megahertz. That's the bandwidth required for 4G, with excellent conditions, megabits per second speed. Now compare that with 300 terahertz. That's not just an order, multiple order of magnitude higher. So compared to 20 megahertz in 4G, here potentially we have, let's say 100 terahertz. That's almost 10 to the power 6 times the spectrum. So theoretically speaking, obviously this is theoretical, there are no physical implementations available which operate on terahertz, but theoretically speaking, I can have a mobile phone on visible light based communications which can at least download data maybe in terabits per second, right? That's a huge potential. There is a lot of potential in this technology. So we have free spectrum, we have huge amount of potential in terms of the spectrum available in terms of bandwidth. There are also other advantages. One advantage is in terms of security. You can also view this from privacy perspective. When you send data to your base station, the data penetrates through walls. So if you're sending something from here to the base station, anybody can eavesdrop. But of course there are encryption technologies on top, but they do receive the signal. The signal propagates very well in non-line of sight. The same is not true, for example, for this LED. If I am sending data to this LED, or let's say the other way around, if data is coming from this LED to my mobile phone, even the person sitting at the last row may not receive anything, right? The intensity in non-line of sight for visible light is really low, and it does not penetrate through walls. You can view this as an advantage. You can also view this as a disadvantage, depends on the use case. So I am saying for the use cases that we are targeting, for example, for indoor use case, this is a good advantage to have. It will have only line of sight propagation, so you will have inherent security in your communication system itself. It will also be low complexity. Why do I say low complexity? Low complexity because To send data, you just need an LED. You just need a diode, photodiode. To receive data, theoretically speaking, you just need a photodetector. They are very cheap, very easy to implement technology compared to RF transmitter and receiver, where you have to do a lot of things on top. The technology in visible light domain is going to be much more simplified, right? So hardware-wise also, it is relatively more simplified or less complex. It will also be energy efficient. What's a typical Wi-Fi router's power consumption? Any idea? How many watts it takes? Feel free, make a guess. One watt, 5 watt. You have to be a bit louder. Sorry, we have asymmetric channel conditions. I have a microphone, you don't. So you'll have to be a bit louder. Yes. Please, go ahead, make a guess. Roughly around 5 watts. If you are not using a gaming router with a lot of hardware involved, it will at least take 5 to 10 watts. How many watts this LED takes? Typical LED. Again, 5 watts. 5 watt is a reasonable LED. You can obviously go till 100 watt and more also, but we don't deploy them in the indoor scenario. For indoor scenario, there's hardly 5 to 10 watt. So each of these LEDs is essentially a 5 to 10 watt LED. Please also note, these LEDs are not just communicating. They are also being used for illumination. So we have an advantage here that we can use the same LED for communication and for illumination, both combined. So that's why the notion of energy efficiency. And it can serve the dual purpose of illumination and communication, right? So with that as a background, as a motivation of why probably visible light communication is going to be a technology to look forward to, let us move on to the actual technology itself. So it's not a hypothetical technology. See, there are technologies which are like very futuristic, which we say, okay, somebody has thought of an idea and they start coining a term that, we'll do visible light communication. No. It has already been done. There are already prototypes available. There is already, for that matter, a standard available. So we have IEEE 802.15.7, where the whole physical layer implementation is already defined. And it's not a new standard. The standard has been around now almost 10 years, right? So the standard has been around for visible light communication in the IEEE domain. And it defines the physical layer, right? How many of you are familiar with physical layer? OSI layers, 7-layer architecture? Not yet? Data networks? Okay, it will come eventually. I'm presuming this is the EC crowd, right? Or a CS crowd, right? EC, yes. So then maybe as an elective it will come. For CS students, it's I think a core course. For EC students, maybe as an elective, but I would recommend it. Even if you don't have in your curriculum a course on computer networks, I would recommend you to do at least 1 credit online, just to get a perspective, how things work, right? Everything should not be motivated by GPA and credits only, right? Something should be self-interest motivated also. So anyways, so please check out if you can, if you have the time and the bandwidth to do a 1 credit course on computer networks. So there are these layers. For any communication technology, you typically have a notion of 7 layers or abstractions, in which the bottom layer is the physical layer. The physical layer deals with how physically the bit will be communicated on the channel, right? And how it will be received at the receiver. So the transmitter and the receiver architecture is well defined in the physical layer, which is the lowest layer in the OSI layer architecture. So for visible light communication, in IEEE 802.15.7, the physical layer is already defined. For that matter, 3 physical layers are defined. I'll only be highlighting one of them because that's the one we have been working on. But there are 2 other versions also. I will project them, but not go into the details. So when you go to the physical layer, for example, you need to tell, okay, what should be the modulation? When I say modulation, it essentially means if I have my bits and I want to transmit them in the LED, I need to change the intensity of the LED, for example. Let's say I dim the LED, that represents 0, and full strength means 1. Or switching off means 0, switching on means 1. That's one of the most basic forms of modulation, which is also called as on-off keying. Because you're EC students, you will definitely do a course on digital communications. Already done digital communications? Not yet. That will come for sure. Maybe others here can confirm, but I think communications will definitely be a core course for them, at least in 3rd year, I believe. So in communications, you'll be studying modulation technique. So essentially here we are modulating light. In your mobile phone, we are modulating the RF signal, right? In your Wi-Fi router, again, we are modulating the RF signal at a different band. For example, in Wi-Fi, you're modulating it at 2.4 gigahertz or at 5 gigahertz. Whereas in cellular, it depends where the operator is operating, right? Which spectrum. In this case, we are modulating the visible light spectrum, right? And we are going to keep it simple. So for example, in this case, for this standard, one simplest possible modulation scheme is the on-off keying, where we switch on and off based on whether it's a bit 0 or 1, right? Even before we do on-off keying, they have something called as a run length code. In this case, it's a Manchester code. Why is this needed? So hypothetically, please note the sequence of zeros and ones. It is not deterministic. For example, let's say I am sending a message to all of you in digital domain. That sequence of zeros and ones is random from your perspective, because if you already know, there is nothing to communicate, right? If you already know 5 zeros, 3 ones, 2 zeros, 5 ones, you already have the message with you. So the idea is, from a receiver perspective, the sequence of zeros and ones is random. Because the sequence of zeros and ones is completely random, it can so happen that you have a long sequence of zeros followed by sudden ones. Then again some sequence of zeros, then ones, right? It can be any order. Now please note, in on-off keying, I am keeping the light off when it's a bit 0. And I'm keeping it on when it's a bit 1. Now imagine for 1 second, it is all zeros. And then next 1 second, it is all ones. Would you like it? Light is on for 1 second, off for 1 second, on. No, it's very irritating. So what we don't want is, we don't want the same LED when we are using for communication and illumination. We don't want that flicker effect, because it's not good. You know, it's very tedious for that matter if the light is flickering. So to avoid flickering, in this case, it's very simple. Manchester code is one of the most basic codes. For that matter, run length limited codes are really old codes. Why am I saying old codes? I'll give you a perspective of how old they are. They are older than me, right? So I am 35, roughly. And these run length limited codes have been around since the days of hard disk. So those primitive computers in 1970s, which were using some notion of storage, even at that point of time, people were looking at some sort of run length limited code, right? So that's another topic in itself. Let's not digress. Coming back to our topic, we want sequence of zeros and ones should not be such that we have a long sequence of zeros and then a sequence of ones, because then we'll have flicker. So to avoid flicker, in Manchester code, what we do is, for every 0, we send 0, 1. For every 1, we send 1, 0. So for every 0, we are sending, let's say hypothetically, 0, 1. For every 1, we are sending 1, 0. So they are both unique, right? The advantage is, when I send this kind of run length limited code, no matter the sequence of zeros and ones, what is the maximum consecutive number of zeros I can have? You agreed on the mapping, right? Let me repeat the mapping. For 0, I am sending 0, 1, 2 bits instead of 1. And for 1, I am sending 1, 0. Right? In this case, no matter the sequence of zeros and ones, the output will be 0, 1, 1, 0, 0, 1, 1, 0, something of that sort. So maximum number of consecutive zeros is 2. Excellent. If it was my class, I would have said bonus mark. Typically give bonus marks for this. Nevertheless. So now, the advantage of this code is, of this Manchester code is, it is limiting the run length. You can only have either 2 maximum consecutive zeros or 2 maximum consecutive ones. After 2 zeros, there will be a 1. After 2 ones, there will be a 0. Right? So we are limiting the run length. Because we have limited the run length, the issue of flicker that we were discussing earlier, that will not occur. Right? What is the disadvantage? The disadvantage is, if earlier I was sending at 1 megabit per second, now I am sending at half megabits per second. Because for every 1 bit, now I am sending 2 bits. So I am reducing the rate by half. So rate of this code is half. It's a half rate code. So we have Manchester code before performing on-off keying. We also have something called as forward error correcting codes. Why do we need them? See, typically the channel is lossy in nature, right? It's not that when I transmit 1 or 0, I will receive it with 100% probability, right? The channel can have its own errors. For example, let's say this is a transmitter, and this microphone is the receiver. And while talking, all of a sudden my hand comes in between. So those bits will be lost. So there should be some way to recover certain number of bits, right? So this is called as channel coding, or also called as forward error correcting code. So in this case, we are using a combination, So in this case, we are using a combination of an outer and an inner code, but you can use any other forward error correcting code also, right? Again, you will be hopefully studying part of this channel coding in digital communications. I will not go into the details of forward error correcting code, because then again we'll be digressing a lot from our topic. But the idea is we try to, similar to Manchester code. See, Manchester code is not a forward error correcting code. The objective of Manchester code is to reduce run length. But we can also design codes that you take, let's say, input k number of bits, you have an output which is more n number of bits, you introduce some sort of redundancy, for example, and then we use it to either detect or correct errors, right? A most basic example is, let's say, a repetition code. What is a repetition code? So let's say I speak something and it's not very audible. But if I speak the same thing 5 times, with certain probability, increased probability, there is a chance at least out of those 5 times, 1 time you will listen correctly, right? Very, very common, right? So similarly now, this is the most basic way. There are more advanced way to design forward error correcting codes. So we have some notion of forward error correcting codes here. Now this is the basic physical layer for visible light communications designed in IEEE 802.15.7. This itself suffers from various issues. One issue, as I mentioned, was run length. It can be taken care of by Manchester code, but then that decreases your rate. Now, there is a trade-off, right? I don't want to reduce the rate. All of a sudden, instead of, let's say, 1 megabit per second, you start telling me now your Wi-Fi router speed is going to be 500 kbps. Doesn't feel good. So that's one thing we can, probably work on. Another thing is perfect DC balance. So there are other codes. This is not the only run length limited code. There are other physical layers. If maybe I'll quickly project. So for example, this is the physical layer 1 itself, right? It has Manchester code with these forward error correcting codes and these kind of data rates. Please look at the data rates. Obviously, it's an old paper. It's like 10 years old paper, right? So that gives you a perspective of how old the technology is. It's not that the technology evolved in past 1 year. It has been around for some time. But then the rates are really low. As you see here, 11 kbps, 24 kbps, 250 kbps. If I ask you to buy a technology which gives you 250 kbps, maybe you'll start laughing at me, right? Because those are not the kind of the rates you're used to in current domain. Coming back to the run length limited code, so we have Manchester code, we also have 4-bit, 6-bit code. What's a 4-bit, 6-bit code? A 4-bit, 6-bit code essentially means you take 4-bit as input, you have 6-bit as output. And it puts certain constraints on your run length. We also have, so that's one of the issues. So now when we look at a DC balance, for Manchester code, it is perfectly DC balance. Why? Each output combination has equal numbers of zeros and ones. If the input is 0, output is 0, 1, 50-50. If the input is 1, output is 1, 0. It is still 50-50. So when I look at the output, here, it will be perfectly DC balanced, right? But that is not true, for example, for this 4-bit, 6-bit code. This is not a perfectly DC balanced code. In this case, there are certain set of input 4-bit sequences for which the output may have not equal number of ones and zeros. So then what will happen is, when your LED is being used, it will change the dimming level slightly for those sequences which are not perfectly DC balanced. And our human eye is very perceptive, especially to change in brightness levels, changes in terms of flicker and all. And we don't want that. When we are trying to use visible light for both communication and for illumination, what we want is, we want it to be uniformly illuminated. We don't want the illumination to change much. At the same time, we want to piggyback. We want to make sure we use the illumination for communication also, right? So this is different from other optical wireless communication technologies. So there is something called as OWC. OWC is a very broad gamut of technologies. When I say optical wireless communications, it essentially means we are using light for communications. We can have something called as free space optics, where you have highly aligned transmitter and receivers, but they are not used for illumination. So please note, we need to segregate. We need to make sure what we are talking about is essentially a technology for indoor illumination and communication both, right? Coming back, so we have an issue of perfect DC balance. We also have an issue of PAPR. What is PAPR? PAPR is peak to average power ratio. If you are transmitting, let's say, an output wave, if I can call it, or an output set of sequence, in certain scenarios, the peak power of your communication sequence may be more than the average power of your communication sequence, right? In this case, how do we define power? In this case, power is nothing but illumination level. So if I have non-perfect DC balanced codes, there would be scenarios where the output power is 50% of the sequence bits for on-off keying. There would also be scenarios where it is not perfectly DC balanced, slightly lower or slightly more than 50%, right? So in that case, your PAPR will not be equal to 1, right? Another issue is, you must have been hearing about this at least in the 4G domain. So one of the technologies that has driven the growth in 4G domain is MIMO, multiple input, multiple output systems. Same thing can be translated for visible light communication also. Now in visible light domain, I can have, instead of one LED, I can have an array of LEDs as a transmitter. Similarly, at the receiver, I can have an array of photodiodes. So you can essentially replicate your MIMO system, which you are having in 4G and 5G or beyond technologies. Same thing can be done for optical wireless communication also, or visible light communication in this case also, right? Now, the challenge is the moment you have multiple LEDs. For example, look at these LEDs in this room. I can start jointly sending data from all of them. The catch is, if I'm sending jointly, for example, let's say the LEDs in this row, okay, only 2 are functional, but that will highlight the point. This one is not functional, right? So let's say these 3 LEDs. I'm gonna combine these 3 LEDs and send data jointly. Now what happens is, there might be a scenario where this LED is off, which is in this case permanently, and those 2 LEDs are on, right? So now this will generate asymmetric illumination. There is more illumination this side, there is less illumination this side. So we don't want that. We want the LEDs, even if we are using them jointly, they should have uniform illumination, both in space as well as in time, right? So it's another problem statement that was open at that point of time when we started working this domain. So I just wanted to highlight that. I'll not go into the details of maybe 7 and 8 because that requires certain amount of background, but 6 I'll try. Now, for 2G systems, it was a TDMA system. Anybody knows what's a TDMA system? Time division, multiple access, right? The notion is we divide time as an orthogonal resource and we communicate, different users communicate in orthogonal set of times. For example, first time instance, user 1 communicates, second time instance, user 2 communicates, so on and so forth, right? This is called as TDMA. Similarly, 1G system was FDMA. What is FDMA? Very good, excellent, full marks. So frequency division multiple access is, instead of dividing over time, you divide frequencies. Frequency 1 for user 1, frequency 2 for user 2, so on and so forth, right? Again, it is orthogonal set of resource. In FDMA, the orthogonality is in frequency. In TDMA, the orthogonality is in terms of time. In 3G systems, we have something called as CDMA, which is code division multiple access. So there, instead of time or frequency, we orthogonalize in terms of a code. We have a high rate code sequence, we orthogonalize in terms of that code sequence. Any ideas what do we use in 4G? OFDMA. What is OFDMA? Very good. Orthogonal frequency division multiple access, where the idea is we take the time and the frequency, divide it into a grid, right? Where each block is an orthogonal time frequency resource, right? So again, we are orthogonalizing. Why are we orthogonalizing? So far, at least up till 4G, even in 5G to most of the extent, we try to orthogonalize the resource, because if the resources are orthogonal, the crosstalk between the resources or the interference from one resource to another is minimal because they're orthogonal in nature. I'll give you an example also. Let's say all of us start talking in English at the same time with same power. There'll be chaos in this room. It's very difficult to understand. But let's say myself and the honorable speaker before me, we somehow start speaking in Hindi. The next player starts speaking in English, Tamil, Telugu, Malayali, all sort of languages. Then we'll be able to decipher. Happens. Try it out. Sometimes you can play this as a game also between a group of friends. In a group of 6 or 7 friends, each pair communicates in a different language. They can communicate easily. Because the languages do not, it shouldn't be similar language. The languages have to be different from each other. If they're slightly different from each other, you can communicate. Why? Because they're orthogonal. Right? Similarly, in wireless communication domain, we want orthogonal resources so that multiple users can simultaneously communicate. See, in TDMA, what was happening was multiple users were communicating in time domain in orthogonal fashion. In CDMA, using code domain. In OFDMA, using time frequency grid. But now, in 5G and beyond, we are looking at NOMA, which is essentially non-orthogonal multiple access. And the idea or the motivation is, why to have orthogonality? Let's increase the receiver complexity. Let us use the same resource for more than one user and try to cancel out the interference. Right? So there is something called a successive interference cancellation, which has been around actually for some time, but has been repurposed for something called as NOMA in 5G and beyond. So now these are, and obviously the hardware implementation itself is a challenge. So one of the reasons why the older visible light communication technology implementations are of kilobits per second is because the hardware was a limitation factor. See, it's very easy to hypothetically say, we'll switch on and off the LED. It's very good, na? Come to stage and say, we'll switch on and off the LED, we'll get terabits per second. How to do it? Somebody has to implement the hardware, right? To on and off, you need to have a piece of hardware in the LED. Now, LED is not like our traditional microelectronics, right? There is a great difference when it comes to the LED as compared to your typical circuits. What is the order of current in your circuits? Typical circuits. For example, in your phone, what is the order of current flowing in the circuit to drive the phone, the microprocessor? Any ideas? This you must be knowing. You must have done a course in basic electronics, right? Basic electronics lab, transistors, diodes, transistors, no? Yes? Milliamperes. Milliamperes is also high, but let's say milliamperes. Okay, for our understanding says, let's say milliamperes. What is the amount of current required to drive a 5-watt LED? This you should know. Yes? 1 or 2 amperes. Let's say 1 amps. Right? So 1 ampere compared to 1 milliampere. There is an order of magnitude high in terms, higher, in terms of current. And 1 ampere is not a small amount of current. For that matter, 1 ampere can be lethal. 1 ampere is a huge amount of current. 5 ampere is what we give to AC. So the wiring of AC is different. So these ACs have 5 ampere current because, it's very high current. So you can't use a traditional wiring that we use in the home. That's why we give separate wiring to AC, because the current may go up to 2 amperes in 2-ton AC, maybe up to 5 amperes. So few ampere currents is very high amount of current. Now imagine what we want to do is, at 1 ampere we want to switch it on and off, on and off. As I keep increasing the rate, it becomes really complex to do it. So that has been one of the bottlenecks. So designing the driver circuit for LED has been one of the bottlenecks. So that's why I mentioned hardware implementation. So in hardware, one of the reasons or the bottlenecks has been because you can't change or modulate the output of the LED that frequently, right? So I think most recently we have seen few hundred Mbps per second or 1 gigabit per second kind of implementations, right? Till 5 years ago, people are only talking about few megabits per second. The limitation was not spectrum, the limitation was hardware implementation. It was non-trivial to design the hardware. Maybe let me quickly take a time check also. Okay. So now coming to the actual implementation in terms of IEEE 802.15.7. As I mentioned, there are 3 physical layers already available in this standard, which is close to more than 10 years old. For the matter, not close to, more than 10 years old for sure, because the paper itself is 2012. And one is on-off keying. Another thing that you use is VPPM, right? And there is also something called the dimming structure, which is inherently built in VLC. What is the dimming structure? You must have seen these lights in hotels and all. I'm not sure if these lights support it, but you can buy these lights now online also. There are these lights by Philips and a lot of other vendors where you can control the dimming level. You can increase the brightness, you can reduce the brightness. Or the closest example is your phone. In your phone, you can increase the brightness, you can reduce. It's a LED phone, right? The display is LED. No matter what type of LED, but it's a LED. Essentially, it's an LED phone in terms of display. So now you can increase the brightness level or you can decrease the brightness level without changing the output in terms of the sequence. If you have a picture displayed on your phone, the picture remains the same, the brightness level changes, right? So to support the same for indoor lighting, there is a notion of dimming levels. So we have a dimming structure which is inherently built into the standard itself, where the idea is, if I want more dimming, I'll introduce certain set of 0 frames. If I want less dimming, I'll introduce certain set of more 1 frames, right? 1 is maximum output, 0 is 0 output, right? So dimming structure is also part of the standard. And this is what I was talking about. So you have a frame structure where you have certain set of compensation symbols. So the CS, or the compensation symbol, is what is introduced to maintain your dimming level, right? You can have other modulation techniques also, right? It's not that on-off keying is the only modulation technique in visible light communication domain. We have something called as VPPM or PWM. In VPPM, we change the position of the pulse. For example, bit 0, the pulse appears in the beginning of the time frame. For bit 1, the pulse appears at the end of the time slot, right? Similarly, you can have PWM where we change the width of the pulse. The pulse remains at the same place in the time slot, but we vary the width. We can also have something called as a CSK or color shift keying, because we don't necessarily have only white LEDs, right? You can also deploy a red, green, blue LED. And then you can choose how much intensity level in green, how much intensity level in blue, how much intensity level in the red one, right? Which is effectively what we do in your phone also. If you're looking at your phone display or any LED display, for every pixel, we are choosing the RGB value. Same thing we can do for visible light communication also. And that is called as CSK or color shift keying. So this is the whole frame structure for visible light communication. This is very similar to a frame structure for any other communication technology, right? That was again one of the reasons I am asking you to do a course on computer networks. If it's not there in the curriculum, it will help you understand how different technologies work, right? That kind of motivation is also important. So now, and you can also have 2 other implementations. So one is on-off keying based, one is VPPM based, PWM based. We also have CSK based or color shift keying based. As you see here, the rates are more reasonable. It's going up till 96 megabits, or was defined for up till 96 megabit per second. At that point of time, it appeared to be a reasonable amount of rate, right? But as I highlighted, there were a couple of problems, right? One problem was run length. We don't want large number of sequence of zeros and ones, and there were solutions available. So for example, in this one, there was a 4 by 6 bit code for run length, which provided 50% duty cycle, DC balance, error detection capability, right? Now we wanted to enhance this. So we said, okay, so this is a joint work I have with Uday, who is now he's Dr. Uday. He's a PhD student who graduated from our group this year, and with Dr. Lakshmi Prasad Natarajan, who is a colleague of mine. For that matter, a lot of works that we have done in this domain are joint works between myself, Uday, and Professor Lakshmi Prasad Natarajan. There are other works also. I'll highlight them as and when the time comes. In this work, we said, okay, you have a frame structure. In this frame structure, we are inserting compensation symbols for dimming level. Can we use those compensation symbols more smartly, right? So we thought, okay, instead of inserting the compensation symbols only for dimming control, let's insert them to improve error performance, right? So I will not go into the details of the algorithm because that requires a basic course of digital communications, which at least majority of you, as I see, have not yet done, right? So I will just highlight broadly the work. But at any point, if you want more detail, I'll be happy to share. So here we said, okay, the compensation symbols that I talked about, which are effectively these compensation symbols, instead of blindly inserting them in the first position, for every frame, can I insert them smartly? Can I use them not only for not only for illumination, can I use the compensation symbols also for communication, right? So we were able to do that in a smart fashion, and based on that, our proposed work did slightly better than existing work. So this is mutual information that I plotted with SNR, and I think this one got, yeah. So here, please note, it may appear like a small improvement. Again, you can look at the graph and say, well, it looks hardly one increase. In COM theory, if you can improve performance by 1 dB, not theoretically, this is a theoretical improvement, so this doesn't count. But in practical implementation, if you can improve performance by 1 dB, you can become a millionaire. That 1 dB enhancement of performance by any technology, by any means that you can contribute to, definitely you can become a millionaire. So that gain, that marginal gain, obviously this is a theoretical gain here. So I'm not gonna claim that I'm a millionaire already. No, I'm not. This is all simulation-based study. But in hardware, if you can do this, right, in the implementation level, that has a lot of value. So we were able to show at least one, for that matter, more than 1 dB gain also in certain scenarios. We also compared in terms of the bit error rate with the existing schemes. For example, here we have an outer code, RS1511 or convolution code 13. The proposed scheme we compared with the existing scheme. And as you see, the blue curve is always smaller than the red curve because this is error rate. We don't want more error, right? We want less bit error. So in this case, we were able to show the bit error rate performance for the proposed code was better. It was smaller. The blue one, which was our code, is smaller than the red one, right? The second problem that I mentioned to you guys was DC balance. We want to make sure the output for a VLC code should have equal number of ones and zeros. So this is another work that we have in which we were able to derive certain conditions that given any arbitrary number of input bits, k bits, what are the limits on n and vice versa. For any code, we were able to show that if they satisfy these relationships between k and n, it will become a perfectly DC balanced code. Another way to look at it is, let's say you design a code, any k n code, where input is k, output is n. Using our work, you can cross-verify whether this particular code can be perfectly DC balanced or not, right? We also looked at low complexity, high rate codes, where the idea is, please note, if I am not moving a lot with my receiver and the transmitter is anyway static, the transmitter is an LED, right? It is deployed, it's not going to move for most of the indoor use case scenarios. And using my receiver, if the receiver is not moving a lot, it is mostly static. In that case, the channel is not changing much. If the channel is not changing much, the error performance is reasonably good. Another way to look at it is, we mostly operate in very high SINR ranges or SNR ranges in VLC. For the matter, when we started working in this domain 8 years ago, the output results, let me go back to, or maybe I'll slightly move ahead just to highlight one point. Yeah. So when we started working in this domain, we started getting SNRs of this kind. 100 SNR, 120, 140. If you go to any RF engineer and show them 100 dB SNR, they'll start laughing. Because in wireless communication, in cellular domain, in Wi-Fi domain, Bluetooth, LoRa, Zigbee, the SNR is from -10 to 10 dB. That's the range. -10 to 10 dB. All of a sudden you have a plot which says 100 dB SNR. And everybody went, this is strange, this is too high. Even we were surprised. But then we realized this is happening because in VLC, This hardly 2 meters. It's always line of sight. Nothing is moving. It's all static. Because the channel is so good, the SNR is very high. The signal to noise ratio is very high. Unlike RF. In RF domain, we would see the kind of plots that I was plotting earlier. So these plots, for that matter, we were not using a very realistic VLC model. We were taking the model from RF. Whatever is happening in RF, similar model you are applying with small changes. But then we realized the actual visible light communications SNRs are much, much higher. Now in that case, if the SNR is so high, we don't need to invest a lot of effort in error correcting codes and in all those things. So we were able to design, in this case, high rate codes with very low complexity, right? For that matter, we said take a k set of bits. If the SNR is really good, 99.999% of the time, it will be successfully transmitted. Another way to look at it is, the bit error rate will be like 10 to the power minus 5, 10 to the power minus 6. Only one bit in 10 to the power 6 bits will be in errors, right? So then, why to invest so much effort in error correction? You take some k number of bits, you just append them maybe at the end with one bit. If there are even number of ones, for example, you put 1. If there are odd number of ones, you put a 0, right? It's a very, very crude way of doing a checksum. But then this also works. So we were able to show even simple schemes like this, which can be implemented in hardware very easily. They work and they give relatively good performance because the channel is so good. Then another technique or another issue that I discussed in the beginning of the slides was PAPR, peak to average power ratio. Now this is relatively more recent work. For the matter, actually, Uday did his MTech and PhD with us. So he did a MTech 2-year program, completed it. So this work is his last work from MTech. I think this was in 2018. Then he joined Qualcomm in Hyderabad and continued his PhD with us. So the follow-up works are all from his PhD and then some other works also. So now in this work, by this time there were many works happening in the domain of visible light communication, and one of the issues everybody was targeting was PAPR, peak to average power ratio. So as you see here, there are so many works, and a tick means, single tick means PAPR 1. 2 tick means PAPR is high. 3 tick means PAPR is even higher, right? We don't want PAPR to be very high. Why? If peak to average power ratio is very high, your circuit, which is driving the output transmission, at some times it will be transmitting at peak power, which will be very high. And most of the times the average power is lower. See, PAPR means peak to average power ratio. If PAPR is high, means peak is much higher than your average power, right? On the other hand, let's say PAPR is 1. PAPR equal to 1 means the peak power and the average power are the same. So effectively you are transmitting at constantly same power. On an average, the power remains the same. So now, with PAPR equal to 1, which is single tick in this case, it is relatively easier to design the circuit. Because circuits are not linear in nature. Circuits have a lot of non-linearities when you design the hardware. If PAPR is high, the peak power transmission may not operate in linear regime, right? Again, you must have studied voltage current characteristics for diodes, for BJTs. Have you? How many of you have studied? Again, yes. So that if you look at those voltage current characteristics, it is not a straight line forever. It curves. We don't want the circuit to operate in the curved region, because in the curved region, for marginal enhancement in performance, you need to put in more energy, right? So driving the circuit is much more difficult. So in this case, we were able to design a technique which achieved good PAPR, relatively better spectral efficiency than existing techniques, but of course the spectral efficiency was worse than the techniques which have higher PAPR. So if you look here, we are not claiming the best spectral efficiency, and that happens a lot in research. You can't have everything better all the time. Very difficult. You can, I'm not saying it's not possible, but when you're designing techniques in research, a lot of times you say, okay, there are 2-3 things we are looking at. One thing, for example, in this case is, let's say bits per channel per use. You can translate this to rate. So a scheme here with higher value will have higher rate. A scheme here with lower ticks will have better PAPR. Now traditionally, either you have higher PAPR, right? or you have higher rates. So we wanted to design a technique with relatively lower PAPR with some compromise on rate. Right? Again, you may think, there is a faculty from IIT, what is he telling us? Compromise. In research is very common. See, in just like in real life, when you're doing research, when you're designing techniques, we don't have a magic wand. We can't say, okay, here comes a technique with ideal PAPR and maximum rate. Rare, very rare. What we can do is, okay, PAPR is one type of performance metric, rate is another type of performance metric. There are schemes in this 2D space. So let's say this is a 2D space, PAPR is x-axis, rate is y-axis. There are schemes with high rate with bad PAPR. There are schemes with good PAPR but bad rate. Can we design something in between? Can we design something with better PAPR, slightly less rate? That itself is an enhancement, because for certain regimes, we need those kind of techniques. We can't operate always on the fringe, right? So in this case, we were able to design a technique which had low PAPR with uniform illumination for MIMO VLC. So we achieved two objectives here. The third one I didn't highlight so far. So we achieved uniform illumination and low PAPR in visible light-based communications. Again, as you see, our performance was comparable in terms of bit error rates as compared to existing schemes. If you look closely, it's marginally worse. It's not better. So the blue line here, the bit error rate is slightly higher than existing schemes, right? But we are gaining in terms of the PAPR and we are gaining in terms of illumination, uniform illumination. I'll have more similar surprising results as we go forward. So then we started focusing on uniform illumination. We said, okay, if you're going to deploy multiple LEDs across space and time, what we would like to have is we would like to have uniform illumination in space as well as in time. What do I mean by this? As the example given by me earlier, if I have these three LEDs and I'm using these three LEDs for communication and illumination, I want them to be uniform in space. It shouldn't be that this LED is always off and the other LEDs are always on. That we don't want. Another thing that we don't want is that for 5 seconds this is on, then next 5 seconds this is off. No, individually each LED should be uniform in illumination. Jointly also the LEDs which are communicating together, transmitting together should be uniform in illumination. So we tried to design a MIMO code for uniform illumination across space and time, and what we found out was, unless we introduce, at least for us, again this is a limitation on our thought process, it may be possible to design it otherwise. So I'm not claiming it is not possible, but for us we thought to design a scheme with memory is more plausible. So we went ahead and designed a scheme which had some sort of memory in the system. With this memory-based scheme or these memory-based codes, we were able to achieve uniform illumination in both space and time. Those are the results I'll be projecting as we go forward. So for example, this is a description of the scheme. Again, in interest of time, I'll not go into the details on how we achieved it. The broad idea is that similar looking codes, you club them together. For example, if my input sequence is 0, 0, 0, first time I receive 0, 0, 0, I transmit this message. Next time I receive it, I transmit this message. Then next time I transmit this message, then S3, then again S0. So in this fashion, I have a cycle. In this cyclic fashion, I keep on going. So there is a memory. This memory has to be retained at the transmitter. This memory also has to be retained at the receiver. The receiver should also know, after receiving the first time S0 successfully, next time when it is decoding, it should be decoding for S1 and not S0 for this sequence of bits, right? So it slightly is more complex than the schemes we have discussed so far. But the advantage is, no matter how many times I receive 0, 0, 0, 0, each LED will be illuminated at least once. If you look at the structure is such that the number of LEDs and the amount of illumination is constant. For that matter, in this case, each LED is illuminated for A. That is how the scheme is designed. With the scaling constants and all, the idea is, on an average, each LED gives A as an output in space as well as in time, right? So we are able to achieve that. Now, as I mentioned earlier, there are no free lunches. Now what we wanted was uniform illumination in space and time. There is obviously has to be a cost. In this case, there is a huge cost. The proposed scheme is this one. If you look at the bit rate performance, there is roughly 10 dB loss for our proposed scheme compared to existing schemes. So these are the existing schemes, right? The red and the diamonds, the black diamonds. These are the existing schemes. Compared to the existing schemes, we have a 10 dB loss. So you can always go back to my statement and say, you said 1 dB millionaire. Here you have 10 dB. What are you doing? But again, see, there are no free lunches. We are doing this because the existing schemes do not have uniform illumination. If you use those schemes with the existing LED structure, there will be huge disparity in space and time in illumination. Whereas with our proposed scheme, obviously there is a loss in performance, but there will be uniform illumination across LEDs. And I have results which support this. For example, here, this is the average. So you can look at this as the average transmitted power over the 4 LEDs with increasing number of iterations. 50 times the bits have been transmitted, 100 times, 500,000, 10,000. Even after 10,000 times the bits have been transmitted, the average power for our proposed scheme is 5.2, right, across 4 LED. For existing schemes, the variance, it keeps on increasing. Initially it is 56, becomes 11,000, 19,000, right? This is variance. How many of you are familiar with variance? Standard deviation. So square root of this is standard deviation. I think this, this is variance. So you take a square root. So this is essentially, you can take a square root here, it will give you the standard deviation. So the standard deviation for our scheme is more or less constant. It is not a function of how many bits have been transmitted. Whereas for the existing schemes in these codes, the standard deviation keeps on increasing. So as you keep transmitting, the variation or the standard deviation in the existing scheme keeps on diverging. This is also true at per LED level, because at the beginning I told uniform illumination in space and time. So this is space now. So now let's look at 4 LEDs. For all the 4 LEDs, again take a square root, because majority of you are familiar with standard deviation. So same number, take a square root. That's all. So now, if you look at the variation for our proposed scheme across LEDs, it's more or less the same. Even after 10,000 iterations, the standard deviation is square root of 5, square root of 5, square root of 5 roughly, right? But for the existing schemes across LEDs, the numbers are drastically different. They are increasing. So here, for example, square root of 120/100 is roughly 110, right? So it can be minus 110 here and plus 110 here in terms of the illumination level. That can be the order of magnitude difference between the illumination level across LEDs, right? Because they are not transmitting with a constraint of uniform illumination, whereas our scheme is transmitting with a constraint of uniform illumination. So we are able to achieve uniform illumination across space and time at the cost of bit rate performance, right? There is always a trade-off. Okay. So then, this is another work. So besides this, so this is for the matter, I have just presented a subset of work that Uday has done in a group for his MTech and PhD thesis with myself and Professor Lakshmi Prasad Natarajan. But there are other works that I've been also doing in the VLC domain. I'll just highlight some of them based on the available time. I think we have 10 minutes. 1 o'clock is the end time, right? 5 minutes, sure. So we have also looked at hybrid systems. So let's say you want not just VLC, because VLC, one constraint is downlink is straightforward. From LED to your receiver, it is straightforward. What about the uplink? Should I deploy LED in my phone? Where should be the photo detector, right? So one way communication is relatively easy. The other way it is non-trivial. So one way to solve that is, on the other way, either you use IR, infrared communication, so that the human eye doesn't perceive it. Because if there is a light here now, 5-watt light coming out of my phone, that is not convenient, right? It's cumbersome. So either we use that, or we can use RF. So we can have VLC on the downlink, Wi-Fi on the uplink, for example, right? Or we can use other existing techniques. So we have looked at hybrid setups where we are using power line communication, VLC and RF. This is a joint work. Again, Dr. Reddy graduated from our group. So myself, Dr. Ankit Dubey from IIT Jammu, Dr. Panigrehi from NIT Goa, and there are other collaborators also, but by and large, we all worked together with him for his PhD thesis, which was around this domain of visible light communication and resource allocation. And so we looked at these hybrid systems and how they can result in improvement in performance. We have also looked at NOMA, which I was highlighting earlier. I was talking about non-orthogonal multiplexes, right? Where you have TDMA, FDMA, CDMA. So we were able to design techniques which operate on non-orthogonal multiplexes. So NOMA techniques for VLC, these are more recent work that I have. For example, this one was published at the beginning of this year itself, where we were able to show better techniques in NOMA for VLC for, let's say, beta number of transmissions. I'll not go into the details of this, but we designed several type of decoding techniques in this case. So when you are receiving data from multiple channels, how to combine them, right? And we were able to compare and show better performance than NOMA. So this is another collaboration that I have primarily with Dr. Mani and Dr. Kishore now. Dr. Mani is with NIT Warangal. I've been collaborating with her for some time. Where in her group, they have been looking at the hardware level implementation. So they have looked at this USRP based implementation where you take a USRP, connect it to this kind of a bias T, connect that to a LED module, modulate light, then add receiver photodiode, connect it back to a USRP. And all this, so if you remember the beginning of my slide, there was a frame structure, there was a physical layer implementation for IEEE 802.15.7, right? Same implementation, which we have done theoretically, at least what I have presented in the beginning was theoretical. This was done in hardware, right? So with different type of modulation techniques in hardware for visible light-based communication, this is another work that we have. And it gave better performance than the state of the art. I'm not sure if it will be possible to play the video. It's a 2 minutes video. Can you please try to play it? So this is the implementation that we have worked on in our group, which is a hybrid implementation. So one part is visible light communication. You need to just press it. Sorry? You can just click it. It should play. Yes. Yes, just once, yes. Audio, I'm not sure if there is a possibility of audio output from there. But nevertheless, the idea is one PC is connected to a photodiode. I think we'll be zooming into it. Okay, so the first one is the PLC one. So PLC is power line communication. So effectively, you can use the power line for communication also. So we have worked on this hybrid PLC VLC setup. So where we take PLC transmitter, goes into PLC receiver, which then converts it into a VLC transmitter, which goes into VLC receiver. So one hop is power line, the other hop is visible light communication. We are able to obtain few megabits per second as expected from the standard implementation, but at least we have something which works. So it's not just theoretical. We are able to send and receive. So whatever we type here on the first PC, same gets received on the second PC through PLC, and then same gets received on the third PC through VLC. So that kind of an implementation we have been able to do. Audio, I'm sorry, I'm not sure how to integrate, which is fine, no problem, no problem. So here we are typing some text. Greetings from, as I mentioned, Dr. Ankit Dubey is my collaborator. We have a joint project. For the matter, we completed the project this year, a DST project on PLC and VLC implementation, along with NIT Goa. Dr. Panigrehi was the other collaborator from NIT Goa. And then the LED is there, right? This was on for some time. There is a photodiode here, and the same message appears here then. But of course, here we are not doing it real time because we want to show it for a demonstration purpose. So it's not to show how many bits per second we can pump in the system. It's just to show it works by and large. So same message appears here through VLC channel. Right? Thank you. You can maybe end the video. Yeah. So I work in other domains also. Right? It's not that I only work in visible light-based communication. I also work in machine learning for vehicle, human drone detection. That's one of the key areas that we are more recently been working on. resource allocation for NOMA and any 5G and beyond technology is actually mostly what I have been working on for past almost 10 years. Security and privacy is another key area in wireless networks that we are working, more predominantly for IoT, maybe another workshop, another time. Also, I have looked at subjective video quality aware scheduling in cellular networks, communication for swappable battery in light EVs, and now cellular vehicle to infrastructure kind of communication. So there's a broad gamut of a broad set of topics that I work on. I always, whenever I go for a talk like this, try to highlight our department. I belong to the Department of Electrical Engineering. We have around 32 faculty members. We have BTech, MTech, PhD programs. We have these 4 core specializations. I belong to communication and signal processing, but we also have power electronics and power systems, systems and control, microelectronics and VLSI. We have close to 516 students. This is not for the institute. This is our department. And we have 212 BTechs, 136 MTechs, 168 PhDs. For that matter, we have more grad students. If you add these two, we have 300 plus graduate students, only 200 undergrad students. We are a research-driven department. We have around 14 labs for research, 15 teaching labs, more than 200 crores in research funding for our department. Again, these are numbers not for IIT Hyderabad in general, this is only for our department. So the motivation of presenting all this is that we are always looking for students, for graduate students. And if any of you is interested in pursuing masters or PhD program, please reach out to us. I'll be happy to connect and see how I can help you. I also have another slide deck. I'll skim through it if possible. Can you check? I shared one more PDF. That's my email address. If you can also Google it. It's available on the internet. You can just Google Abhinav Kumar IITH. You can find it. But nevertheless, if you need one, it's right here. That's my email address. Feel free to drop me an email. I may not respond the same day, but I will respond. So there may not be a lag time in between, but I will respond. I also have a very short, if I can use 2-3 more minutes, please. Is it okay? Yeah, sure. Thank you. So just to highlight our grad programs, right? This is a set of presentation more recently we have created on MTech and PhD programs. Will be relevant at least to some of you. Please, next slide. You can just go to the next slide. It doesn't matter. Now, please note, although I say I belong to the group of communication and signal processing, right? That is what I would like to highlight. So our group works on information systems. That includes wireless systems and standards, green and next generation communication, image processing, video processing, speech processing, information theory, compressed sensing, IoT, bio and healthcare, signal processing, cognitive radios, blockchains, big data. These are kind of the systems we work on broadly. 5G and beyond communications, right? And we use different type of tools for this. We use math, like linear algebra, matrix analysis, probability theory, optimization algebra. We also use machine learning and AI. For example, deep learning, neural networks, distributed and federated learning, statistical learning theory. The idea is to highlight to you guys that it is not that communication and signal processing is just about the math part. We have communication and signal processing systems. We have mathematical tools. We also have learning and AI driven solutions for them. And our group is working at the intersection of all of this, right? So if you're interested in any of these topics, please feel free to reach out to us. I'll not go into the details again, but there is one slide I have. Yes, this one. So this is one question that I don't have an answer to. So I always project these numbers. So these are placement statistics for our 3-year MTech array. This is a subset of companies because some companies put a non-disclosure agreement, so we don't include their names in such slides. But by and large, these are some of the recruiters which come on campus for our 3-year MTech program. I'm not going to advertise a 2-year MTech program. I think most of you are aware of 2-year MTech program through GATE. This 3-year MTech, this is the average package in CTC in lakh, right? So it's not a bad number, right? But still we are not getting as many applicants. Now there is obviously a trade-off, just like research in real life also, there is always trade-off. For a 3-year MTech, the trade-off is you have to spend one extra year, right? The advantage is you get to work more on the research. So if you are not sure whether to do a PhD or not, immediately after BTech, a 3-year program might be better. This is the closest you can get to a PhD program, right? So if you probably, for whatever reasons of yours, want to pursue a career in research, maybe consider applying to a 3-year program in communication and signal processing. That is what I'm trying to sell here. We also have a sponsored MTech program, which is a 2-year program, which has slightly higher fees. Please check out the details online. This also has a good received well in the industry, right? So again, these are 2 programs I just wanted to highlight: the 3-year MTech RA placements as well as the 2-year MTech sponsored placements. In terms of the fees and stipends, it is more for sponsored, definitely. This is the regular fees, right? In terms of the stipend, typical stipend is around 12,400, but that's the least you will get. So if you pursue a 3-year MTech with us, the minimum stipend you will get is 12,400. But that you can receive more also. For example, a lot of students in my group are getting 25K per month. What I don't have an answer to is why some students join jobs which are equivalent or slightly better than that amount, but not join us. Right? I request you to please consider our 3-year MTech program. The scholarship can be higher than this for the 3 years. The placements definitely are of this order. This is the 3-year MTech placement. So you will be reasonably well placed if you go to the industry. If you plan to do a PhD, the research output from your 3-year MTech would potentially help you get much better PhD opportunity. So I just wanted to share these details with you. We also have a PhD program. For that matter, the eligibility for a PhD program is just a BTech. If you have BTech with GATE, you are eligible. GATE also in certain cases, for example, for 3-year MTech, we waive off the GATE if you work with us for 6 months. So for example, if you start working just after your BTech, if you work with us for 6 months in one of the projects, even the GATE requirement can potentially be waived off in such certain cases. So my request is, please think about our programs. I hope I have motivated you enough to pursue an MTech or a PhD program, whichever you are interested in, and do explore our programs online. And if you have any queries, do reach out to us. The selection process, for example, for 3-year MTech and PhD is very similar. We conduct online or in person based on COVID and other constraints an exam. We conduct our own exam on top of the GATE. If your eligibility is GATE or experience or working in project with us, in any of those cases, we conduct our own exam. Then we shortlist you for an interview, and then we shortlist you for the final offer. But my request is, please consider. And if you have any queries, do reach out to me. I'll be happy to connect, and help you out. I already shared my email address with you, and I look forward to some applications from your side. I think it's mostly majority second-year crowd, if I'm not wrong. But nevertheless, maybe 2 years down the line, it's an investment, right? So please consider. And if you have any queries, let us know. We'll be happy to conduct more sessions with you. These sessions now, as all of us know, can be online also. We don't have to be in person all the time. But feel free. Even now, if you have any query, I think I'll conclude at this point. If you have any query about the talk or the programs, I'll be happy to answer them. Thank you. Thanks a lot. Yes, please. Yes. So the work that I presented, we are sending different data. So it depends. So it depends on what kind of setup you are looking at. So you can have a MAC channel, multiple access channel, or you can have a broadcast channel. The work that I presented, I think, was for broadcast channel, but we have works for both. And there are other works also where you can send. So essentially each LED can be used as a different spatial multiplexing can be done. Yes. Yes, it will be. So I think that is where the beauty of these MIMO techniques comes into picture, right? So independent of the VLC domain, in RF, for example, MIMO codes have been around since 1990s. And at least till 2010 and all, there is 20 years of work which has happened, which tries to address this, right? That whether we should do diversity or we try to do spatial multiplexing, and are there schemes which achieve both? Similar works have been happening in the VLC domain also. Yes, can be done. And there are, again, you can look at schemes which try to do both in the VLC domain, can be done. Yes. But in our group, we have not done it so far. We have only looked at because things have moved on to non-orthogonal side of the NOMA kind of things have started coming to picture, right? So we have looked at NOMA for broadcast channel in VLC, and we have looked at NOMA for MAC in VLC. But if you're looking at spatial diversity and multiplexing mix kind of a scheme, we have not yet looked at it. But there might be others who have looked at it. Definitely it is possible. It's a good topic to work on. Yes. Yes. So energy efficiency, I think, yes. Yes, yes. That is true. So when I say low complexity, it is low complexity because the channel is not varying that much. See, in RF domain, please sit. The RF domain channel is highly varying, right? For example, when I have my mobile phone here, a lot of times you might have experienced this, especially in regions which have bad signal quality. You shift the phone a bit, it becomes 4 dots. You come back, 1 dot. Have you seen this, right? In RF, it happens. And this is happening because the channel is changing very fast. There are a lot of things which are uncertain in the RF domain, right? Things between the transmitter and the receiver can also change. Maybe I'm receiving good quality because there was a car parked, car moved, I'm not getting that signal anymore, right? Unlike this, in VLC domain, the channel is highly deterministic. For example, here, from this LED to this microphone, we can actually mathematically derive the channel, and it will be very accurate derivation of what the channel is going to be, right? Because the channel is so deterministic, we don't need to use the fancy techniques from RF domain. So we can use less complex techniques because the channel is nice, right? Another way to look at it is, in conventional terms, if we are talking now, let's say I don't have the microphone. If everybody starts talking, then I have to shout to talk to you, right? That is RF, complex. In VLC domain, nobody is there. Nice channel. Or if they are there, they are not talking. I can simply talk to you, even without microphone. I can talk, you can listen. So the complexity is less, right? So that's an analogy I would like to give for complexity. Similar thing we can look at from energy efficiency perspective. Now in energy efficiency domain, because we have so much complexity, so much hardware has to be deployed in the RF. So phone, although phones transmit power is less than 1 watt, but phone does not only consume 1 watt. There is so much processing happening in the baseband and otherwise, right? But in VLC domain, the physical layer that I presented, it was so simple, right? 3 blocks, forward error correcting code, then your relevance limited code, and then your modulation technique. So compared to your RF implementation, the power consumption or the energy efficiency will be better. I hope that it helps. Yes. Another reason for better energy efficiency is we are piggybacking. We are not using it only for communication. If you look at only for communication, 5 watt is very high. Phone takes less than 1 watt. Here we are taking 5 watts. But because that 5 watt anyway is being used for illumination, we are just piggybacking. So it is a change on top of the 5 watt, the plus minus that we are using for communication. So the incremental change in an existing infrastructure in terms of energy consumption is marginal. And that is why we are saying it is more energy efficient than RF. Already, the light has already been deployed, right, for illumination. So I hope that helps. Yes, sure. Any other queries? Okay, thank you. Thank you, everyone.
Thank you, sir, for providing detailed insights on various research scopes available in visible light-based communication, and also the various opportunities that students can avail at IIT Hyderabad. Now I request Dr. Satish Kumar sir, Ramesh sir, HOD Department of CSE, and Munishekar sir, HOD Department of IT, to felicitate our speaker, Dr. Abhinav Kumar sir. So before we officially provide a vote of thanks for the inaugural session, lunch is arranged for all the delegates, authors behind new auditorium, and they can use battery car to move over there from here. The same thing is provided for all the guests and the guests present here. Now, on behalf of the organizing committee of ICSVCE 2022, I propose vote of thanks to all the participants, the students, the authors, and all the dignitaries present over here. Thank you for attending the inaugural session. After lunch, we'll continue with our paper presentations at the designated venues in Block 3, room number 3001 and 3003. So everybody can disperse for lunch. Thank you, everyone.